Hi, I hope everyone has finished your sketch exercise given in your project workbook. Definitely, you should have finished all the sketches in the stipulated duration. Now, all will be interested to listen how the part model can be created in SolidWorks. So, what exactly part modeling makes? The part modeling is nothing but the process of creating components, models, using sketch-based features, and also using treatment features. You will shape the component. Extrude, revolve, sweep, loft, all this we call as a base feature, or we call it as a sketch-based feature, because these command will create a feature based on the sketch, and we call it as sketch-based feature. So the part model will be created based on the sketch-based features, and you will modify it using treatment features like fillet, chamfer, etc. And once you create this, definitely you will have a clear idea what and how the model can be created in SolidWorks. For this, I'll give you a small example in SolidWorks. This is a model which is used in the miter saw machine, which is used for wood cutting. This is a side cover for belt. Let's see how we can let's see how this part is created in SolidWorks. First, I'll need to go and activate this SolidWorks part reviewer, and I need to rewind this. And once I rewind this, I can play step by step the process involved in this. I'll go and play. Now I can see it will create the features automatically. That is, we are just reviewing the created feature, and this will give you an idea how a part model is created using feature after feature. This is what we had first discussed in the first class. It is introduction to SolidWorks, and here you will be able to see different functional features are added one by one, and once you can create the features one by one, you will require to convert the whole model into thin feature. And that will also be able to do in SolidWorks by using smart tools such as shell, and you will be interested to know how this can be done in SolidWorks. Of course, we are going to see all the commands in detail in the later session. And there is one more interesting thing. If you have 50 commands, we cannot drag and we can understand this. What you can do is, from this area you can understand which command is right now it is playing. And here you can see the command right now it is playing is split line. And once this is finished, this icon, this top icon will highlight. That is, the play icon and other 4 icons will be inactive. Now you can see the icons inactive. This shows that the process has been completed. And definitely you will be interested to see how this component is used, where it is used. To show this, I would switch back to the miter saw assembly, and here you can see how this has been created using SolidWorks. The entire process cannot be shown in this short video clip, but this model will give you a view that creating model in SolidWorks is as simple as possible, and you can create the design smarter and also in a more realistic way. After this, we are going to see creation of datum plane in SolidWorks, which is acting as a datum for the part model creation. In part modeling, understanding a reference plane is essential one for a designer. The reason is, a reference plane is the datum for a feature creation. Feature is created from sketch. and the sketch is drawn on the reference plane. To create any geometry, you require to understand how this reference plane can be created in different ways in SolidWorks. Reference plane is simple. If you want to make it understand clearly, it is a datum plane where you used to draw all the sketches. From there you will build the features one by one, and you will also use as neutral plane for different purpose according to the different application. When you create reference plane, you need to define first reference, second reference, and third reference. First reference, you will define the first constraint, and second and third accordingly the plane will be generated. Now let's look into the different type of plane creation in SolidWorks. Let's see how we can create reference planes in SolidWorks using different types. And here you will be able to see the images which is showing how a coincident plane is created, and how a parallel plane will be created, and a perpendicular plane. And here there is an image which shows plane projected on a surface. And we are going to see in SolidWorks, let's see how we can do this. The first one is creating the plane coincident, that is passing through one point. I select this face and I will select this midpoint. I need to select a point. I'll delete this and I'll make it as a point here. You can see the plane is coincident with this midpoint. This we called as coincident point. Now for the third reference, if I select this end point, the plane will be created passing through this third reference, and that this is called as plane created using three references. The plane can be created using second reference and first reference, and also we can create using first, second, and third. Now what I will do is I will give you one more idea of creating the plane, that is parallel plane. I want to create a plane parallel to this face but passing through this point. Here you need to use parallel, and here you can give coincident. Now what I will do, I will not use this coincident, and I will say remove this, and I will say this is my edge, and here I need to use parallel. You can see the parallel plane is created, and simultaneously if you select perpendicular, you'll be able to see the plane creating perpendicular to the face but passing through this edge. This is how you can create parallel and perpendicular. The next one is creating the projection plane. The same plane, this is my first reference, and the second reference is this face. Project this. Now the plane is projected nearest location on surface, and if I use along sketch normal, and now it says it is invalid, you flip it so that you can get the sketch normal to the face with the reference of this point. This is how you can create datum plane in SolidWorks. And now the next one is there are other four types of creating the datum planes: tangent, at an angle, offset distance, midplane. Let us see this planes one by one. First one, I'd like to show you a tangent in SolidWorks. It is tangent plane. First reference, second reference. Both the references we are given tangent constraint, and the plane is created tangent to this face. And now I would like to create three datum planes at an offset distance of incrementing at the distance of 20, 20, 20. What I will do, I'll go to geometry, plane, select this face. Here you can see a distance. Here I can enter distance, how much you need, and if you enter the number of planes, you'll be able to create. This is how you can create using first reference but using the distance constraint. And you can also create number of planes in one single stretch. And this is useful especially when you create sectional views or when you create sections for an loft feature. And let's look into the plane created in an angular way. To create an angular plane, you have to go to once again plane, select this face and select this edge. Second reference is this edge. Now you can see the plane is created perpendicular to the face. All what you need to do is select this at an angle and you can enter the values here. Now you can see the plane will be oriented according to the input angle, and you can use flip to define the plane orientation. And we have one more interesting thing, creating midplane. For this I have one more specific file. I'll go to this arm link. I would like to create a midplane, that is intersecting plane. Go to plane, here I'll select the first face and second face. Now I'll be able to see midplane created between these two faces. And this is all about creating a datum plane in SolidWorks. And now let's see the remaining tools, commands involved in SolidWorks for creating smarter designs. The first command in part modeling is extrude. Extrude feature will convert the sketch into a 3D model or a sketch into a feature by extruding the sketch normal to the sketching plane. And this command is called as sketch based feature. Here you can see a sketch is extruded normal to the sketching plane and using an handle here. And when you drag the handle, you will have the option of defining using this deviation scale. And now we are going to see how we can extrude in two different directions and different start and ending condition, and how we can apply draft angle and how we can merge two solid bodies. And this image will give you an example of draft applied on the extrude feature. Now let us look this one in SolidWorks. This is a closed profile. Now I will go and insert the command from this command manager, or you can choose from the insert menu, going to base extrude. Select this plane, and now you can see material is added normal to the sketch. And when you use this handle, you will be able to give the increment using this deviation scale. And when you want to define the direction in two directions, that is, the material should be added in two directions, you can use this checkbox and you can drag the other side. And when you are creating this, you have an option of applying draft. You have the icon draft on or off, and you can here apply the draft angle. And once you apply draft angle, you can click OK and you can complete this process. Now the extrude can be created normal to the sketching plane, or you can define a direction also. Let's see how we can do this. I'll go to extrude, boss or base. I'll select the sketch, and for direction we are using this sketch. And now you can see when you drag this, you'll be getting the material added parallel to this sketch, selected sketch. This is how the direction can be defined. And once you define direction, it is up to you. You want to use a thin feature, or you want to be as a solid one. And now let's look into creation of extrude, creation of thin feature using extrude command. I'll go for a new file. Here I will create an open profile. I'll go and choose front plane. Here I will create an open profile. And once you complete this, you exit this and go to extrude. Now you can see automatically this open profile will be converted as a thin feature. Here I enter as 5 mm, and if I enter auto fillet corner, the corners will be applied with fillets and it will not have any sharp edges. Once you complete this, you can give OK, and you can get a thin feature in this graphical area. And Let's see one more example of creating a thin feature but with capped ends. I'll go and say this feature has to be created as a thin feature, but it should be closed. It should be like a shell-like element. It should be a thin feature, but it should be closed. I'll go and choose extrude once again, select this. I will use thin feature, but this time I'm going to create, but this end should be closed. I'll choose this. Now if I select here, okay, this will be a thin feature, but I need it should be closed. You can go to cap ends. Here you will select thin features, and I need to extrude symmetrically about this plane. And here, using thin feature, you can define the thickness. Before that, what I will do, I'll go and say I need blind, and after defining the blind direction in one direction, and the next you want to define this cap ends, and cap end distance how much? I need 3 mm, and click OK here. Now you can see the feature has been created. Go to the sectional view and use this plane, and you can look this feature created here. And this is how you can create thin features in SolidWorks using extrude command. And this is what we had defined here. Creating thin feature and applying corners for the sharp edges, and using cap ends to close it. And now let's look into one more example of selecting the contours. I'll close this file. I'll go and choose the select contours. So selecting the contours, I need to have first the predefined sketches. I'll go and choose this one. Here we have intersection entities, but here I'm going to use only the closed region. Go to extrude, select this profile, but I don't require thin feature. What I will do here is I'll go and clear this, and now I will choose the region here. So now we are using the contour selection, and we are doing extrude here, and I need this to be symmetrically distributed. Click OK, and now once again I will highlight the sketch. I'll go to extrude, I'll select the sketch, and now once again I need only this profile and this closed loop, and I need this to be symmetrically distributed, and drag this and click OK here. And this is how we can create from the intersecting profile, but it should have a closed region so that we can create a feature. And at last we are going to see one more option in extrude, and apart from that we are going to see a different end condition for extrude. Now I will take one more hands-on file from this SolidWorks which I had drawn previously. I will go and say I would like to see the result of merge. Here this extrude is created from this closed profile. Okay, and we had given an option called as merge result. Okay, but in this example we didn't give any option, like we didn't check this merge result. Let's see the difference here. You can see this solid is not exactly merged with the solid. That is why you can see difference on this edges. And moreover, you can see there are 3 separate solid listed in this feature manager 3. Now once again we'll go and choose merge result, and I'll click OK here. And now if you look, you can see the difference. It is exactly welded with the solid, and you will see only one single solid, where it will not show you the solid bodies folder. It makes us to understand there is one single body. Next, end conditions. When you create a feature, you have to define the end condition. You have to define how the feature should end. It has to travel throughout, or it has to stop at any intersecting surface. And here you can see there are 8 different end conditions you can give in extrude command. Blind, as you know that you can enter the value how much you need, and through all, it is nothing but creating a feature passing through all the features. And this image will give you an example of feature extruding up to the next intersecting surface, and this is extruded up to the selected vertex. And in this end condition you can see the feature is created exactly up to the selected surface, and the end of the feature is offsetted to a distance from the selected surface. And here you can see a feature is created between two solid bodies. And now let's look all this end condition in SolidWorks. First one, through all. I'll select this sketch and I will remove the material by using extrude cut, and here I will use through all and click OK. Now we can see the feature is created throughout this feature. And now let us look into up to next. Let's go to the one more predefined hands-on file. Here I had just completed the partial portion of the YouTube. I cannot say YouTube, it's an pipeline, and now I need to attach one more feature exactly up to this surface. I'll go to extrude, I'll select this profile and I will say up to next. And now you don't want to choose anything, it will exactly create up to the next intersecting surface. And the next, up to vertex. I will choose and one more hands-on file. Here this is my profile, and I'll go to the command extrude, select this profile and flip the direction, and here I will choose as up to vertex and select a vertex here. And you can see right now it is extruded up to this vertex. Still you can define direction if it is there. And now one more interesting thing is creating or ending the feature with respect to the surface we select, that is up to surface. I'll go to up to surface, and here you can see an example. There is a revolve body. I need to extrude this circle profile to the selected surface. I'll select up to surface and I'll select this face. Now you can see the feature will be exactly ending with this selected face. And once you complete this, next we need to understand how we can create the feature exactly up to the body. I'll go to up to body, and here we need to choose this profile. Let's understand how this part has been created. I created this is separate revolve body and this is separate revolve body, and I created a circle, and this is the line segment which defines the extrude direction. Go to extrude, select this profile, and direction is this way. And once I decided this, I would like to say up to body and select this body, and we need to flip the direction, and the second direction once again up to body and select this bottom one. Now you can see the feature has been created in between two bodies, and we need to say feature scope all body so that this will become as a one single body. And if it has become one single body, you cannot see the list in the feature manager design tree, which indicates a single body. And now let's see one more end condition in SolidWorks, that is offset from face. I'll go for offset from face. Here this is the sketch. Select this, go to extrude, extrude in this direction, and I need to use offset from surface, and this is the surface, and here you can see the end condition is exactly offsetted from this face. You can choose the distance from the selected surface, how much you need to enter. How much you need to enter, you can do it here, and if you make as 2 mm and if you make it as translate, the end condition will be different. Okay, and click OK, and the feature has been created. That's all about end condition in SolidWorks. As of now, we had seen the end condition for an extrude feature. Now we are going to discuss starting condition for the extrude feature. One is sketch plane, where the sketch where you are going to sketch on the, where you are going to create on the plane, from there it will extrude, and you can offset or you can select a face, from there you can extrude it. Let's see how we can do this in SolidWorks. And this is an example for offsetting from the face. I'll go and say extrude, and I will choose from here offset, and what I will do here is I will extrude this, but I will say it has to be offsetted from this plane So what I will do is I will enter the value here 20. Now you can see from the sketching plane it is offsetted, and once again you can see vertex where you can select where it should start. From here it should start and end, it should end up to this surface. This is how you can define start and end condition. Let's see one more example for this. I will go for embossing this text on the surface. I'll select the sketch, I'll go for extrude, and here you have surface plane. I can select this plane, and from here you can see the feature will be extruded, but when you look in the top view you can see it is exactly following the shape of this revolve body. That is, the end condition, the starting condition will take the shape of the surface. And this is all about start condition in extrude. As of now we have discussed the thin feature created using extrude, end condition, start condition, and using selected contours you can create feature from the closed region. Instant 3D in SolidWorks will help the user to modify the model by using drag handles and rulers. This Instant 3D will be activated once you click the icon on the command manager, and this Instant 3D will work both in part and assemblies. Let's see how we can use the Instant 3D for designing our component in SolidWorks. This is my model, and now I need to add material for this sketch. I can select this. You will have this handle and you can drag this. When you drag, you will have the ruler on this. We can define the depth for this, or you can, if you drag on the inner side, you can see material will be removed. So this is what the intelligent it has in Instant 3D. And when you click this, you will have option of giving either a draft on the faces, or you would like to have only cut. What do you need, you can apply here. And once you define this, now you decided this feature has to be dynamically modified. You have to increase the height or you want to decrease the height. You select the face and drag this. You can see you will have the ruler and you can define the depth for this. And similarly, you can show the sketches. If it is not exactly not given any dimensions, you can dynamically you can change this by using Instant 3D. And if you see this, Instant 3D can be activated from this command manager. You can see here Instant 3D. This has to be selected to get this handle. If you don't select this handle, you will not get this green color handle. If you activate this, you will have the handle over here, and you can drag this to increase the height, or you need to decrease the height. This is what Instant 3D in SolidWorks to work in a real-time workbench in creating the model as simple as possible. Components like valve, alloy wheel, steering wheel, bottle, these components, if you look, they all have cylindrical geometry. And when you want to create these type of shapes, definitely you have to use a revolve feature. Here you draw a profile on one side and you will use an axis to revolve that sketch around an axis. And this slide, you can see an example. There is a sketch and there is an axis, and the valve is created by revolving the sketch around this axis. And here you can see an alloy wheel. The section is revolved about an axis, and the alloy wheel is created partially. And you can also create thin feature using revolve feature command. Let's see how we can create in SolidWorks. I'll go to sketch. I'll create a 2D sketch on this front plane, and first one I will use center line, and now I'll go and say a profile I need to create. So I'll start with a rough profile for creating the alloy wheel, and here I would like to end up like this. And once I complete this, I would like to close this, and once I finished, you can give confirmation corner here. I'll go to feature, revolved base or base, select this, and automatically the center line is selected. If you don't require, you can select the manual lines over here. If you want to revolve on the other line, I'll use this as an axis and I'll click OK here. Now you can see the partial alloy wheel has been created. Still I can complete this. I can go to the top plane and I will create one more center line here to make slots on this and line on this. Before I need to apply vertical constraint, and here I need to create one more profile. This is for defining the slot on this alloy wheel. I'll create an arc on this, first, second, once again here one more arc. Once I complete this, exit, and using extrude cut you can remove the material. And before this, what I will do, I'll once again go to the sketcher environment and I'll say I need to create multiple copies of the same sketch. I'll select this entities, and once I selected the entities, I need to define the center point. It is defined automatically, and I will say number of slots, it should be 6, and click OK here and done. And now you can see alloy wheel has been created. You need to apply still all the you need to apply filler, chamfer wherever required. This is how you can use revolve command to create components like alloy wheel. And now let us look into one more example, the different end conditions in revolve command. Here you have a flat sheet under this profile. I'll go and choose revolve command and select this profile, and I need this to be the axis, and here I will choose up to surface and I'll select the surface. Now you can see it is selected up to the surface, but you need to reverse the direction and you can see the revolve feature up to the selected surface. Once again, you can define offset from the surface, and you see in the front view it is exactly offset from the surface. You can define the distance, it will exactly create normal to the surface, and I'll click OK here. Now let's look into the creation of thin feature using revolve command. I'll go for new file. I will use front plane and I will create one more profile here, that is an open profile, and I need to apply fillet on this edge. I will apply chamfer on this edge, and once I complete this, we need to define an axis. So once again I'll go and edit this and I will define an axis here. I'll use a center line and I will draw this. I'll orient the plane normal to the view, and this has to be exactly located on this center point, or I can just leave as it is. And now let's go to the revolve, select this profile, and now we don't require to be closed. I'll select this profile now. This is my profile, but this is my profile. I think it has to be deselected, and once again I will go and do it. I'll go and say this I had created wrongly. So what I will do, I will go and say position this exactly to this origin, and moreover this should be lying on this segment, that is axis. Now let's see how we can create it. Go to revolve browser base, select this, and here you need to define thin feature, and axis has been defined. You can just drag this angle to some limitation and you can see the thin feature created here. This is how you can create thin feature in SolidWorks. This is a sample exercise of creating a swing bracket in SolidWorks. This will give you an idea how the model can be created using extrude command, and if required you can use hole command, but as of now we don't know hole command, so we will create the entire part model using extrude command, that is adding material and removing the material. Now I will go to SolidWorks environment. I will choose my first I will orient in the trimetric view, and I will choose the right plane, and I'll go and sketch this face I would like to create. I'll go and say create a circle here, and this circle has to be has to have, this circle should have 40 mm as the diameter, and I'll go to rectangle command and I will create an rectangle here, and I would say this corner has to be trimmed. And now this should not be in diametrical dimension, this should be in radius. And once I complete this, I can say all these 3 points should lie horizontal. And now we need to define the distance for this. The distance is 84. And once I complete this, exit the sketch and see in the trimetric view, go to extrude, and I would like to define symmetrically, and this length is of 10 mm. Click OK, and we need to create this feature, this rectangle plate I will create. I'll go and say extrude, select this face, orient the screen normal to the view. It is orienting the sketching plane parallel to the viewer, and I'll create a center rectangle. I'm sorry, I selected the center point wrongly. Now I'll select the point exactly, and this should have a length of 74 and this should have a length of 40. And once I created, I'm exiting this, and the width of this is 6 mm. And once you complete this, you can go and create this 2 features. Before that, we don't have plane there. I'll go and say insert reference geometry plane, and what I will do is from here, that is the right plane, I would like to offset a plane of 25 mm and click OK. I'll select the plane. Before that, I would like to choose one more plane also. We need to create. Go to insert reference geometry plane, select this plane, flip the direction and say this should be 50 mm. Click OK here. Now I'll select this plane and I will choose sketch icon and I'll create the plane. And here we need to use circle, and I'll create the first basic one, and this should be of 40 mm radius. Once again, we need to trim this. Before that, I would like to hide this plane so that it will be easy for me to create the profile. This line should exactly match with this. I'll go and say this, and once again this edge, this point has to match with this, and trim this middle one. And I'll create a circle over here, and this should have a diameter of 16, and this has to be in the radial dimension. And I would like to close this, so I'll select a line over here, and the dimension for this is 25 mm. Once you created this, confirm this area and go and say extrude, select this profile, and now the thickness is 6 mm. Click OK here. Now I can choose one more plane here, and I need to draw the sketch, not required. What you can do is select the existing sketch and go and say convert to entities. Now you can see all the entities which you used in the previous feature, you are copying exactly on the plane. And once again, you can go to extrude and flip the direction and say 6 mm. Yeah, we had completed at almost 90%. This bottom cylinder we had to add. I'll go to extrude, select this face, orient the plane, and I will choose circle command, and I will say this is of 25 mm, and I need to create a hole of 16. I'll create it later. I'll go and say this has to be extruded normally, but what I will do here is I will cancel the command, because this sketch I need to draw exactly on the top plane. So what I will do is I'll select this one and I'll say edit sketch plane, and I will choose the top right plane as the sketch positioning. Now the sketch is on the right plane. Select this, go to extrude, and it has to be symmetrically distributed, and the length is of 50 mm. And once you completed this, the final one is we need to make a hole on this face. Select the face and create a circle over here, and this circle should have a diameter of 16 mm, and click OK and use through all so that the metal will be removed all over throughout the cylinder. And now the model is completed. This is how you can create a part model in SolidWorks. Fillet. Fillet is a treatment feature, or we can say it is an applied feature on a part. Fillet or round creates an rounded internal external face on the part. The need for fillet is to avoid sharp edges and also avoid internal stresses acting on the part. You can apply fillet on the faces or on the selected set of faces or selected edges or edge loops. Here you can see the frame of a mountain bike, where you can see all the frame will be having rounds, and this connecting rod you can see fillet applied on the edges. And now let's see different type of fillets available in SolidWorks. The first one is constant radius fillet. Using constant radius fillet, you can create a fillet having a radius constantly from starting to end. And you can also create multiple radius fillet, round corner fillet, and you can define a setback fillet for a corner. Let's see how we can do this in SolidWorks. This is a clamp holder. Now I would like to apply fillet for this. I'll go and say fillet from here, or you can choose from insert, features. Here you have fillet round. Choose this. Here you have different fillet types: constant, variable, face fillet and full round fillet. I'll use constant radius and I will select this edges. And now you can see I will deselect this face and I select this edge, and 10 mm I will make it as 2 mm, and now you can see the fillet is applied. But in one single operation I need to apply 1 mm radius for these edges. Do I need to exit the command? Not required. You can go to multiple radius and select this edge. Now you can see you can apply different radius for different edges. And this edges I would like to enter here the value as 3 mm. And for this edge I will enter the value as 1 mm. And this edge I would like to enter the value as 0.5. This is how you can create constant radius and also multiple radius fillet for the clamp holder. And next I would like to show you the advantage of using round corner fillet. I'll go to the next file. Here this is one more component. I will apply fillet on this edges, and the value I need on this edges, let's say I need to enter 3 mm. And if you see the preview, you can see all the corners. It is looking like having a sharp at the ends, at the sharp corners. All the corners are sharp. So what I need to do is I can go to fillet options, and here I can say round corners. If I use round corners, you can see this edge will be rounded. And there is one more interesting feature. When you are creating any consumer products, you need to apply a stylish end. Now let's see how we can do this. I'll go and say fillet. I'll select this edge and this edge and this edge. Here you can see we have a corner, but this corner has to be defined in a different way. I mean, it should have a stylish corner. I can go and say here where is the option available, setback, and here you can see vertex. Select this vertex and you can define specific radius. Here I'll make it as 0.5, and this I'll make it as 1 mm, and this I'll make it as 2 mm. Now you can see we have 3 different parameters defined for this corner. They will create a setback at this corner, and I'll click OK here, and you'll be able to see a different corner formed at this edge. This is how you can create constant radius fillet, multiple radius, and you can also round the corners, and you can also apply setback. The next type of fillet, variable radius fillet. In this slide you can look the images, seat cover, hair dryer, partial view, and the top view of electronic gadget. Everywhere you can see the edge will have a round, but that round will not be constant from start to end. It will start here with radius as 20, it can end here as 5, once again it can end with 20. And if you look this component, you can understand the geometry. And if you look this top view, you can see it is clearly shown here. And let's see how we can create this in SolidWorks. I'll go to graphical user interface. This is a chunk. I would like to apply the variable fillet on this edge. I'll select this edge. Before that, we need to choose variable as the fillet type. Select this edge, and here you can see unassigned, and here you can see unassigned. I'll make it this first one vertical as 20, and here this one as 20, and I need to add here and one more radius, that is 5 mm, and here I would like to say here it should be once again 20, and this should be once again 5. Now you can see we had applied variable radius on this edge. If you required additional radius to be added, you can increase this points. If not required, you can keep as it is as 3, and you can make it either straight transition or it should be a smooth. But this you can see a difference when you deviate from a higher radius to lower radius. This is 10, and this I'll make it as not this one, and this one I make it as of 1 mm, and here now you will be closely looking into this geometry, and I will say straight transition and smooth transition. You can see the difference over here, and click OK to create this variable radius on this edge. And the next one is face fillet and full round fillet. Face fillet is used to apply fillet between non-adjacent faces and non-continuous faces, and full round used to create a round on the whole surface, that is between 3 faces, between 3 adjacent faces we will apply a round. Let's see how we can create this. I'll close this file, and now let's go to the hands-on file available here. I'll open this, and here first let's see how we can apply face fillet. I'll go to fillet, I'll use face fillet, and here I would like to apply this face and this face, and here we need to give the radius as 50. Yeah, you can see the radius, that is the fillet has been created, and just click OK here. Now you got this face fillet. And now let's see how we can create full round. Go to fillet once again, full round, select this first face, second adjacent face, and third adjacent face. Now you can see full round is created. Similarly, we can create on the other side, selecting this first face, second face, and third face. Click. Now you got full round on the 2 faces. And this is how you can apply full round. And there is one more interesting feature in SolidWorks which we discussed earlier in the Sketcher environment, that is Sketch Expert. Similarly, in Fillet we have Fillet Expert, which we call as an inbuilt intelligent feature in SolidWorks. This is an basic base feature. Now I would like to apply fillet on the edges. We'll go and we'll select this edge and we'll apply. I'm sorry, what I will do is constant radius. Now what I will do is I will select this one single edge, but I need to apply similarly on all the edges. But what we'll do, we will go and select manually all the edges. But when you have Fillet Expert, what you will do is you will select one edge. It will give you an call out where it will give you an option. You want to select the whole feature or the entire body or only the vertical edges, and you can apply a radius how much you need and apply here. And once you apply this, if you want to modify once again, you can select this, go to change, select this feature and say it has to be resized as 5 mm and give resize. Only this edge will be resized. This is the advantage of Fillet Expert. Similarly, you can modify the corners and you can also add the fillets one by one as per your requirement. It's all about fillet in SolidWorks. Chamfer. Chamfer is used to create beveled face on the selected edges or selected faces, or you can apply a corner chamfer to a vertex. And chamfer is dimensioned in three ways. One is angle into distance, distance into distance, and vertex. It is defining the three parameters for a vertex. Let's see how we can define this chamfer command in SolidWorks. This is a clamp holder. Now let's see how we can apply this chamfer on this edges, and let's see how we can apply the parameters. Go to chamfer, and here I will use angle into distance, and I'll select this edge and I'll make it as this to be 2 mm, and the angle is 45 degree. And once you selected this, you will have the option of defining either angle into distance or distance into angle. Whichever way you need, you can do it here. I'll make it as once again 3 mm. You can input like this. And if you want to make a chamfer for this corner, what you can do is go to once again chamfer. Here you have vertex, select this corner, and the distance, I think we had to reduce this. I'll make it as 1, and this should be 1, and this should be 1. And now you can see equal distance, and I think we had to zoom this properly so that we can see the view of this. And here I'll make it as 5 mm, not required. We require only 3 mm. Now I can see a corner chamfer has been created. So chamfer is used to remove sharp edges, and it is also used for assembling the two components so that it will accommodate the other component to go inside. And this clamp, you can see we had applied a bevel face here so that the other component can go easily into this cylindrical face. And now swept feature. Swept feature is a sketch based feature where the feature is created by moving a profile along a path. We are moving a section along a path, and the components like clamp used in work holding device, spring which is having the helix geometry, thread cutting where you need to remove the material along a helical path, and Allen key. These are the components where you require the sweep command to create the geometry, since here the section will be traveling along a guide path. And now you will be interested to know how this feature can be created using SolidWorks. To start with, I will first create clamp using sweep command. I will sketch a profile on the top plane. This is my circle. I would like to view in trimetric view, and I'll create one more line segment here. Before that, once again I'll orient this, and this is the way, and one more line I had to create from this end to this end, and these two lines should be equal, and I need to trim this. And now we need to do dimension for this. This is of 60 mm and this is of 80. Once I created this, once again I'll modify this as 120 and exit this. And we need a plane to place the section. Go to plane, reference plane, select this line segment and this endpoint, and on this plane start to create one more profile which you need to travel here. I'll go and say I need a profile like this, which will give me the clamp shape. Once I created this, you can apply dimensions if required so that it will be easy for you to control it parametrically. This is of 7 mm and this should be of 25, and I will select this length, should be of 24, and I will say this dimension should be not required. I need to say it has to align here. So what I will do is I will select this point and this point. It has to be pierced. Now it is fully defined. I'll exit this. I'll hide this plane and I'll say I want to sweep this section along this guide path, and click right click here. Finished. And now let's see how can we create one more swept feature in SolidWorks. I will delete this. I'll go and create Allen key in SolidWorks. My first requirement is I'll go and sketch on this top plane. First we'll like to create one line segment. After creating this line segment, what I can do is I can just drag this, I can just switch over to arc, and I can say this is my arc, and up to here I need to create one more line segment, and this should be tangent. And now we can make a dimension for this. This should be of 15, and this should be of 25, and this should be having 160. And once you complete this, confirm it, and now you can go out and say select this plane. You want to select the reference plane, and you can select endpoint, and the plane is created normal to the line segment, and we have selected this plane, and here we are going to sketch. I will choose polygon command, and I will place it exactly on this point. And once I complete this, I don't want to do dimension for this. I will exit the sketch, and I will say I don't require, I need to hide it so that I can have a better visualization. I'll go to swept boss or base, select this profile and select this guide path. You'll be able to see the Allen key creation. Now let's see how can you create helix, that is spring in SolidWorks. I'll delete this helix, that is Allen key. Let's see how we can create spring in SolidWorks. I'll go to insert, curve, helix curve, select this top plane, and create a circle here. This is the diameter for the spring. Give this diameter as 80 mm and click OK. Once you complete this, go to here height and revolution, define here as 120 mm, how much height you required. I require 250 to be the height, and the revolution should be 50. Or you can make it as height and pitch, and I can make it as pitch to be 20, or you require pitch to be 50. How much you require, you can do it here. Click OK. Once you complete this, we need the reference plane to create the sketch here. And using this, go to sketching plane. And now here I will use circle command, and I will go and say I need to create a sketch over here, but you can see we are not able to select exactly this endpoint. What I will do is I will select this, and I will say convert entities. But when I select this one, you can see here it is giving an array. So what I will do is I will exit this, and I will go and say I would like to create the same sketch using 3D sketch. And here I need to create on this plane. And now I'll select the sketch 3D. When I create a circle in this 3D sketch, you can see we are able to snap exactly this point. And now I can see it is coincided here, and go and dimension this, and this should be of 20 mm, and confirm it. And once you complete this, once again I'll hide this plane. I'll go to feature, swept boss or base, select this circle and this path. Now you can see the spring has created using swept boss or base. Now let us see how we can create sweep cut in SolidWorks. Here I have a bolt. I need to create a thread on this bolt surface. What I need to do is I'll go to sweep, that is swept cut, select this profile. We have two cut, one is profile cut and one is solid sweep. I'll use profile cut, and I'll select this guide path and click right click, and now you can see thread on this face. This is how you can create different component using swept command in SolidWorks. Next, orientation and twist type in swept feature. In swept command, you can define the orientation for the section that is traveling along the path. Here we have follow path, keep normal constant, and following path and guide curves, and the section is twisted along the path, and once again twist along path with normal constant direction. Let us see how we can create this in SolidWorks. Before that, let us have a small view how we are going to create this. This example will give you an idea how a profile is twisted along a path. And here a section is traveled along a path and it is guided by two curves. And here the example shows you the section is traveling constant along the path. And now let's see how we can do this in SolidWorks. This is the geometry which is used in handles of any component. This is only a partial portion of it. Let's see how we can create this. I'll go to swept, and this swept command, you need to understand there is one more enhancement we have, that is selection manager. Now we don't require the selection manager. Let's see how and when we'll require this. I will cancel this and I'll go and choose, this is my profile and guide path is this. Once I created a guide path, you can see the path is making the section, means the section is traveling exactly along the path. In this turn, you can see section is exactly making normal to the path. Now I'll go to the options. Here I will say keep normal constant. When I select this, you can see in this area, you can see the section is not oriented to the path. It is creating normal to the plane where we drawn. At the end, what we see the orientation of the section, the same will be at the end. But in the follow path, you can have the advantage of traveling along the path. The orientation of end geometry of the swept will be normal to the path. And this is follow path and keep normal constant. Let us see one more example in SolidWorks how to create a phone card using the section twisting along the path. Go to swept. Here I will use, before that let us have a view. There are two different sketches. I didn't draw two sketches on the same sketching plane. This is one single sketch and this is one more sketch. I'll go to swept. I will select this profile and the next one is guide path. Once I complete this, I need to go to twist along path. Here turns, and number of turns I will make it as 20. And now let's see how many turns will be created here. Exactly the turns, how much you had input here, based on that number of turns will be created where it will allow the section to travel along the path. I'll make this to be 5 and I'll click OK here. Now the phone card is created using swept command by orienting the path along orienting the section along the path. And let's see in the same option, let's have one more view, twist along path with normal constant. If I use twist along path, you just look this geometry how it is created. If I make this as twist along path with normal constant, you can see the geometry creation. This is the difference between twist along path and twist along path with normal constant. And now let's see the other options, that is follow path and first guide curve, follow path, first and second guide curve. Let's see how this guide curves will have influence on the section which is traveling along the path. Now this is the geometry of the connecting rod which is used in engines. Let's see how we can do this. Connecting swept boss or base. Select this profile. Now you will have the application of using the selection manager. Here I will choose, we have different selection method. One is closed loop, open loop, select group, region, and then standard selection. As of now, we'll use region and select this. The next one is I need to select only one single profile. I will go to the standard selection and use only this path, but not able to select. I'll go here and select this, no. So what I need to do is I need to go for open loop and select this one. Now you can see the path is selected. And let's see how we can influence the geometry by giving guide path. I'll go to follow path and first guide, and now we will choose Once again, using the standard selection, not standard selection, select open loop selection method, you select this guide curve. Now you can see the influence of geometry by the guide curve. But now when I input one more guide curve, let's see how this geometry will be created. Follow first and second guide curve, and now I will select one more guide in this area. Now let's see how the geometry is created. This is all about orienting the section along the path. Start and tangency. Previously we had seen how the section will be aligned on the path. Now we are going to see the path alignment in Swift. Let us open SolidWorks. Here let's see the aligning the feature with the end faces. It is aligning the end face of the feature with the faces. Here there is a profile, circle, and there is a helical path. I'll go to swept cut. Here I will use profile sweep. Select this profile. In this selection manager right now we have selection open loop. I'll go for standard selection and select this path, and for the path and for the guide path I'll select this helix curve. And once you choose this, you can see here this end, it is not exactly traveling beyond this face, because here we are given the option as aligned with end faces. If I deselect this, you can see the end condition of this feature. This is how you can define the path alignment. And apart from this, we are going to discuss about path alignment in SolidWorks. Let's see how we can do this. I'll click OK here, and now let's go to the next window, that is path alignment. This path alignment I would like to explain using surface feature, so that you can see the clear geometry difference when I define the path alignment. Surface, I will use swept surface. Here my profile is this, and my path is this one. Select this one, and now let's see the difference. I'll click OK here, and you can see the geometry creation. And once geometry is created, now we can align this path. What I will do, I will see in this view, and also what I will do, I will make this window into two, so that we can have two different views, so that we can understand the geometry creation. This is one, and still we can make it one more view, so that we will have a clear view about this. I will make 4 different views. One is in this direction, and one is top. Okay, and here now let us change this one. First one is, in the option we have path alignment minimum twist. If I use minimum twist, you can see it will allow the twisting of the path twisting of the section along the path in a minimum angle. But when I use direction vector and I choose the direction as top plane, you can see the orientation of the section along the path. This is how you can align the path alignment with respect to the section. That is, section is aligned with respect to the path orientation. Here I will go for one more option, all faces. If I select all faces, this feature, the face 1 and this 2, 3 and 4, all the 4 faces will be created normal to the surface, that is normal to this cylindrical face. And once again I will make it clear, minimum twist will allow the minimum twisting of the sketch along the path, and direction vector, it will give you the option of selecting the direction as a plane, and with respect to that plane the section will be traveling along the path. And this is all about orientation and path alignment. Now let us discuss start and end condition in SolidWorks. I will make this window to be single, and let's go to the path alignment. I'll go to start end tangency, feature, swept feature, and this is my base profile. I'm not able to select. I'll go and choose or region, select this region. Okay, then path is I need to select open loop, and guide curves I will start to select first guide and second guide. Now let's see the difference between this, and third guide I will select so that we can get the shape. Now the geometry is created. Once you created this, you can define the end condition of this geometry. What I will do here is you can see this end condition, how it is created. What I will do, I will go and select one more profile. Let's see whether the geometry is able to create or not. Yeah, we're able to create this. And once this is completed, now I will use start end tangent. So now let's see now defaultly here you can choose it is selected as path tangent. If we use none, we cannot see any difference. Now it is computing. Now you can see the difference. What I will do is I will go and click OK here, and let's see the end tangency with the selection of none. Okay, now I will go and choose this as that is the start end tangency. I will choose here as path tangent, and once I complete this, I'll click OK. Let's see how the path will be created. And also for this I will use path tangent, both the direction I given it. And once we complete this, I'll click OK. Here, done. Then now you can see the difference of the start and tangency. You can see how the geometry is created. It will create exactly tangent at the ending. It is tangent at the end. And this is how you can define the start and end tangency for these type of geometries. And apart from this, you have merge smooth faces. If I deselect this, you can see the hard edges on the surface of the swept feature. You can see this hard edges. But when I select this merge smooth faces, you will not have this hard edges. And also you can view the sections, intermediate sections. You can define here. You can see the sections. This will give the user an overview how the sectional view will be there in the swept feature. And once you complete this, you can click OK. But once you click OK here, once again click OK. And now let's see the feature geometry created. This is how we can create this geometry used in consumer products like Nbox. And these are the different options available in swept feature. Let me give one more view about swept command. We had started with creating components like clamp spring, Allen key, and we also did thread cutting. And after that we had seen orientation twist type. There we had given the orientation for the section to travel along the path. And here we had defined twist, and also we had defined that section to be traveling normal constant direction. And here we had defined start end tangency for the end condition. That is, we are defining the start and end condition, how it should finish at the end and at the start. And here you can see this image will show you the clear difference between tangency applied. And this will give you an option of understanding merge smooth faces. And that's all about swept command. Hope this will give you a clear idea how and which component can be created using swept command. Loft feature. Loft feature is created by blending different sections located at different distances. And this geometry can be created by guiding the sections when they are blended at different levels. And also you will input center line parameter, which we call as spine, which will support the creation of loft feature. Let's see this loft feature in SolidWorks, and these two images will give you an example for creating the geometry using loft feature command. Here pinion gear, and this is oil can, and this geometry is created using loft. I'll go to SolidWorks environment. Here I will use lofted boss or base, first profile and second profile and third. Now you can see the different sections at different levels are blended to create this gear. And when you are creating this, you can see there is a preview with mesh. If you don't like this mesh preview, you can control this by using show preview, or if you want to really control only the meshing on this one, I can go and right click. You can see here mesh preview, clear all mesh faces, and this will give you an geometry in a clear way. And also you can drag this connectors to understand how the geometry can be connected using this control points. And once you complete this, click OK to accept this geometry creation. And this is how you can create pinion gear using loft feature. And here we had seen the creation of pinion gear using the sketches. Now we are going to choose the existing face on a feature, and we are going to create the geometry. I will go to the oil can geometry, oil can bottle. Here I will remove this, and let's see how we can create that geometry. I'll go to lofted boss or base. I will select this base face. We need to cancel this. I will select this base face and this secondary face. Now we can see it is created, but here we need to understand how this geometry can be created exactly, tangency to this face and also tangency for this face. For this, definitely we need to use start end constraints. Here you had to choose tangent to face, and once again here tangency to face. And now you can see the tangency applied to the face, and it will have a smooth transition from this end and for the start condition of this loft feature. And also at this end you can see it has a tangency with this face. And this is all about defining start end constraints, and this is what we are seeing in this slide, start end constraints. And let's have one more example for this start end constraint in creating the door handles. I will go and open the predefined handle which I created previously. I'll open that feature. I hope I just created this where I kept start end constraints, and here you can see sketches we had created, and we are going to see how we can use start end constraints and how it will create the geometry with respect to the start and end constraints. This is my first sketch, second and third. When creating third, we have to define the connecting point, exactly how it should coincide with the other sketch, third sketch. So once you define this, you can now apply start end constraints. I'll go to start end constraints. Here I will use none. This is the condition of none. I'll see in the side view, and now let's see default, and let's see a direction vector. Here I will go and choose, I don't want to define at the end, I will define at the start condition. Direction vector, I will choose top plane. Now you can see the difference here. And this degree is for applying draft on the end faces, and this is for defining this handle. According to this handle, the geometry will have the end condition. I'll apply here 1, and this degree difference, when you orient here, you can see this geometry will have a small draft on this face. You can apply some angle, you can see the difference here, how it will create. I'll make it as 10 degree. Yeah, it is now creating. You can just see how it is created. I will make it as 0 degree. You can see how this geometry is created. and I'll go for normal to profile. You can see one more difference in this geometry creation, normal to profile. I will use here once again normal to profile. These are the different start end conditions you can define in loft command. This is all about start and end constraints. Now let us have a view on creating the guide curves. That is, using guide curves we are going to blend the sections, and let's see how it will influence the geometry creation. I'll go for this loft feature, and here we are going to use guide curves, and that guide curves can be dynamically changed, and that will update the model randomly. Let's see how we can create this. We have two sketches, one is at the bottom and other is at the top. Now I need to create a sketch, but with using 3D sketch, and now I'll click yes, and here I will choose spline, and first point here, second, third and fourth I will coincide here. The same I would like to create one more spline on the other side. Go to spline, first, second, third, and this is my fourth point. And now let's select this edge and this point, and let's say, I'm sorry, this point and this should have coincident. Yes, we have it. I'll click OK, and now I'll go and say feature loft, select this base section and the second section. Once you selected, I'll go for guide curves. This is my guide curve, and click OK, and once again this curve, click OK. Now we had created this loft using guide curves. The advantage in using this 3D sketches, when I define 3D sketch, you will have the advantage of using drag sketch. You can go to drag sketch, and now you select the spline, and now if you drag it, I'll select the spline. I'm sorry, I'll cancel this. I will drag sketch, and now you can choose this to see the dynamic update of the model with respect to the change in the guide path. This is what drag sketch, and this is all about creating the loft feature with the help of guide curves, and this is helpful in creating the geometry when you want to update the model dynamically. In that case, definitely the guide curve has to be 3D sketch. And now let's see how can we influence geometry once again using 2D sketch. I'll go to loft guide curves. Here I need to create a bottle. What I need to do is first one, I'll go to loft boss or base. I'll select this bottom feature. It is bottom sketch, and next one more is this sketch. And once we create this, we can define guide curve 1, but here we need to use this command manager, and we'll go for open loop, first one and second, third, fourth. And apart from this, we can also define centerline parameter so that you'll be able to create the geometry with proper shape. And when you want to understand the centerline parameter, it will act as a spinal cord. If I reduce this up to this condition, you can see how the geometry is created. You will not be able to get the geometry. But once again, if you drag this up to this point, you'll be able to create this geometry. This is all about application of centerline parameter. That is available here. After guide curve, you can see centerline parameter. And this is all about defining start end condition, guide curves and centerline parameters. Let's see once again the slide what we discussed now. One, we discussed how to create these components, and we had defined start end condition for the door handle, and also we had seen similar example in the other geometry, that is oil can, and we had seen the influence of guide curve on the bottle shape. And we are going to see one more example of defining centerline parameters for the geometry creation. Let us take the ram bottom safety wall body. I'll go and choose this part, and we need to create this geometry using loft command. I'll go to loft, select this geometry 1 and 2, 3, 4. Once I create this, now you will be able to blend. Now definitely we need a centerline parameter which is called as a spine here. Select this. Now you can see geometry is created. This is how you can create this geometry using centerline parameter. This is the partial geometry of ram bottom's safety ball body. Let us discuss the other options available in Loft. Drag sketch already we had seen in the last slide when I was demonstrating the feature creation of creating the features using Loft. We had seen a drag sketch, but remember, in drag sketch you need to use 3D sketch as the guide path. When you use 2D sketch, you will not be able to enable this drag mode. And now let's see how we can create thin feature, and let's see the guide curve influence, and also let's see how we can add loft section. I will go to SolidWorks environment. Here I had created a loft feature. Let's see how we can add loft section. And this feature is created by blending two sections, and here we have two guide curves. Using this we had blended, and now I need to add one more loft section in between, and I mean in this geometry I need to add additional loft sections. You can right click here, go to add loft section. You will have a plane. You can drag and you can keep where you require this, and click OK here. Once you confirm that, you will have one more section created here. And once again, if you require, you can right click and you can say add loft section. I need to place the section on this location, and click OK. And you can see here one more section will be added here. I'm sorry. You can see here section 1, 2, 3, 4. So you can see number of sections are added as soon as you apply the add loft section. This is how we can add the loft section to the already created feature. And now let us look how we can create thin feature. Before that, I would like to show you the guide influence on the feature creation. Go to Loft. Using region selection, I'll select first and second, and next I'll using guide curves. I'll select the first guide. I'll select this first guide, and this should be an open loop, so I'll click OK here, and second this one. And now let's have the influence of guide curve here. What I will do is I will place the open loop first. I'll place the cursor over here. Let's see to next guide curve how it will create. I'll keep the orientation in this way, and I'll go and say next sharp. You can see how the next sharp will influence the feature geometry. This is next guide and this is next sharp. So the next sharp, you can see this geometry feature, that is this end, you can see the finishing on this face. And if I go to next edge, you can see this edge will not be giving you the exact shape, and guide global will give you the exact geometry how it has to be created. So it will have the global distribution of the curve. So once again, I will go and do the same process. I will keep it in one view so that you will have the difference of the influence. First is next guide, and second we have next sharp. You can see next guide, and this is next sharp, and next edge, this is next sharp, and this is next edge, and global. This is how you can influence the guide curves on the loft feature. And at last I would end up with thin feature. I have three sections. This is a partial geometry for the cover of an compressor, or it may be the duct of an air conditioner. Go to loft, select the sections one by one, and once you complete this, you need to define this geometry along a path. You cannot use guide, but here you can use center line. Select this center line, and now you can see the feature has been created. You can go and say thin feature, and you define the thickness, how much required here, and click OK. You can see in one single command we had created this thin feature using lofted boss or base. Multiple bodies. Multiple bodies in SolidWorks will help us to create the model in a different modeling technique. So what exactly multiple bodies will mean? In this image you can see the wheel is created, but in one image you can see the spoke is merged with two solid bodies. One is axle and one is rim, but here it is unmerged. So this defines there are three different solid bodies in the design, and this will be appeared in the feature manager design tree. So what is the advantage of using this multiple body? One is you have information about only axle and only rim. You don't have the information about spoke. So you start to design axle and also rim, and later you can design spoke. So this is a different type of modeling technique in SolidWorks where you will realize the importance of multiple bodies. Let's see how this multiple bodies will be listed in feature manager. Here we have revolve, and we have one more feature, extrude feature. This is spoke. And when this spoke is unmerged, you can see there will be three bodies will be shown in the feature manager tree. And if I go to the command, if I say I need to merge this, you can see only one body will be shown here, and this we called as bridging in SolidWorks, and this is what it is explained in this slide. Bridging creates a solid that connects multiple solid bodies. So the importance of multiple bodies is important when you want to create any complex shape or any local operation, or you want to do exactly the operation on one single body. You can use this modeling technique of manipulating the multiple bodies. And the next, let us go and see local operation. In this image you can see there are 1, 2 and 3. There are three different solid bodies, but this we can create as a one single body. But why we are creating in three different solid bodies? The one simple reason is, if I go and shell this one single body, the shell will be applied for the whole geometry, whole solid body, but I need to apply it only for one solid body. In this case you need to have three different solid bodies so that you can avoid the shell applied on the individual features. Let's see how we can do this in SolidWorks. I'll go and choose the hands-on files, and here already it is applied. I will go and remove this. Now you need to understand how this body is created. First, extrude is created. You can see we had created this extrude, and these two is merged as one single body, and this feature, that is this feature and this are merged with this geometries. And the next is the in between geometry. You can see how this has been created. What is the end condition we had given here? The end condition, you can see one is up to body and other is also up to body, and we didn't use merge result, and that's why you can see we can see three list of bodies in this feature manager design tree. And now let's go to the shell command, and now if I apply on this face, and I will say this should be having a 2 mm of thickness, and this will be applied only for this geometry, and I need to apply only for this. You can apply specifically for this face, and this is the advantage of multiple bodies. And now let's see about symmetry model. Symmetric model approach will helpful in creating the feature in a little bit in creating the process. We want to perform it in a short duration without much of performance. Much of the time spent in creating geometry. We can go and use symmetric modeling approach. I'll go and show the model, and here I have one single body. Yes, and I will go for a linear pattern, and here I would take this direction, and I will say the dimension is 54 is the distance between two bodies. And here I'm not going to use features, I'm going to use bodies to pattern. Select this whole body and click OK. Here you can see body has been created. And now once again I need to do on the other side. I'll go and say mirror. The plane is, this is my face, and the bodies to mirror is, this is my body. Now you can see the bodies has been created, but this will definitely reduce the time taken to regenerate the whole feature, because everything is separate geometries, and we can manipulate on each geometry separately when you want to do any operation specifically on those model. I'll go and say feature, and now let's see one single manipulation on this body. I'll just move and keep it over here. Select this, I'll move in this direction, and once again I'll move in this direction and click OK here. This is how you can create multiple bodies, and that can be used for various applications according to the requirement. And now let's see about body intersection. Body intersection, we have three types of approaches. One is adding, and next subtract, and one is intersect. And the image what you see here is intersection. Let's see how we can create this for complex shapes. I'll go to the intersection, tool body. I don't have the model. I'll open this model from the existing file. I'll go and say intersection bodies. Okay, I don't have it. Let us create this. I'll go to the new file. Here the first section I would like to say it should be like this. And once I create this, I will extrude this. And I will say once again in this plane I would like to create one more geometry, that is this rectangle. And after doing this, I would like to extrude on both the direction, and I don't merge here. I need to go say insert feature. Here we have combine. Here we can use add, subtract. I hope definitely you might have seen this Boolean operations in 2D softwares. I would like to show you common. Select this model and this solid body. You can see the preview. This is the combination of two geometries. But what I will do, once again I will change and I will show the difference. Right now it is not showing any difference in the geometry creation. What I will do here is I don't require this shape. What I will do is I will remove this line segment. I will remove this line segment. I will say the shape has to be having a curvature here, and once again here once again I'll create this, and here I need to create one more geometry, and now I need to move on this area. Click OK, and now let's see how this will have the influence, because the normal rectangle doesn't show any difference. We'll go and say combine. Once again select the geometry, show the preview. You can see the top, if you see, it will have the shape, and this right view, if you see, it will have the shape of this curvature. Let's see the difference here. You can see it will have the curvature, and if you see from the top, it will have the shape of the this section's geometry. This is all about body intersection, and this is what it is explained here. Body intersection is a quick way to create complex parts with very few operations, which can result in faster performance. The other modeling technique, tool body modeling, and with the intersection of this we will create a geometry, and we will see how the one single assembly can be saved as a one single part. In the assembly we have number of components, and all will be saved as a one single part. This is especially helpful in outsourcing where you want to share your file, not showing all the components history. You can show only one single part as the assembly. Now let's see about tool body modeling. Here I will go and retrieve. We have the part over here, and this part is also exactly created using this body intersection. You can see here we are using combine. This is the two model, and when we use combine, you can see the combination of these two, we got the geometry. And now what I will do, I will go and say tools, insert. We need to go for part. We need to select the tool from here, and you can place where you required. We have a number of options. I will just place here roughly on this face. If required, you can use translation, rotation, whatever you need here. I will make it in Z direction. No, we'll make it in Z direction. Yes. Click OK here. Once you place this, what you can do is, once again you can go and say feature. I have combine tool. Use comment, subtract what you need. This is the body, and body to subtract is this. Show the preview. Now you can see the body has been created with the external file, which is acting as a tool body. This is all about different modeling techniques available in SolidWorks. Creating reference points. Reference point is one of the reference geometry which is used for creating another geometry or another feature. This reference point is used to create either a feature, or it can be used to create an axis, or it can be used to create datum planes. Where we exactly require this reference points? This reference point, we can call it as datum point, is used in many applications like giving point load, or you can define this point for creating sketch driven pattern, or you can use this point to make the lofted feature to be ending with a vertex point. So this is how we can use reference point for our product development. Now let's see how we can define the conditions and constraints to create this datum points. Go to reference. Here we have point, and from here you can choose the first one, arc or length. You can select this circular arc or circular edge, or this edge. You will create a point here. And next, center face. I can select the face here, and you will get the point exactly on the center of the face. At intersection, you will create the point between the intersection of two edges. And similarly, projection can work when you select a vertex and a surface. It may be planar or non-planar, it will be projected. And let's see how this will work out here. Along curve direction, I can select this curve. It may be a 2D sketch, or it may be an existing edge. You can give a distance, or you can enter percentage wise. If you want to create a number of datum points on this edge, you can increase the number by inputting the value here. And click OK. This is how we can create datum points. And let's see how we can create datum axis, which is used for different applications. And what is about this reference axis? Reference axis is once again used to create reference plane, and also it is used to position the component in assembly modeling, and it is used in circular pattern to define the axis of revolution. And let's see how we can create this. First, I would like to show you one example in using this axis. I'll go to the spring model, and this spring model, when you want to assemble this, definitely you require the axis to be here to position this, but as of now we don't have an axis. What you need to do is go to reference geometry axis, select front and top plane. No, we required the other two, that is right plane and front plane. now you will be getting an axis intersection of these two planes, and right now you can use this axis for positioning in the assembly. And let's see the other example of creating axis. We have online edges, that is, you can have an existing sketch entity or you can select an edge where you'll be able to position the axis. And once again I will use enter and I'll pin this. Now let's see 2 points. You can define 2 vertex point. You can define 2 vertex points starting from here and to here, and this will give you an axis creation. And cylindrical face, you can select any face. It may be this face or this face. You will get an axis here. Point on a face, you want to select a point on the face and one more point on this face. Now you can see point and a face plane. This face selected and point selected axis is created normal to this. This is how we can create reference axis and reference plane in SolidWorks, which is used to create other geometries or other features. To make it one more view on this, points is especially used to create reference geometries and also used to create sketch driven patterns, especially in modeling application. And when you look into validation, you require this point to define point load, and also this reference point is used as the positioning for the components in assembly. And reference axis, once again, it is used in creating the reference geometries like planes, coordinates, and also used to create circular patterns. And this axis is especially used to position the components in assembly too. Coordinate systems. This is one more reference geometry which is used for measuring properties and also used in the geometry to measure the center of mass or the moment of inertia. For every assembly, it is essential to measure center of gravity and center of mass and moment of inertia. All this can be calculated using coordinates. Let's see how we can create this coordinates in SolidWorks. And this coordinate is also useful in assembling the component in the assembly modeling environment. Reference geometry, coordinate system. We need to define first the point. I will select a vertex here, and X direction is this way and Y direction is this way, and now you can see it is oriented. You can flip this to exactly orient to the required direction. Z direction, once again you can define it so that you can exactly control this, and click OK here. Now you can see datum coordinates is placed, and once again this datum coordinate system is used to create table driven pattern where you want to create an whole table. And also in detailing, this coordinates is essential for locating the whole details in the tabular format. And this is all about reference geometries and SolidWorks. So in total we have a reference plane, reference axis, reference points, and coordinates. Using all this, you can create geometry in SolidWorks in easier way. Curves. As of now, we had seen 2D sketches. If we need to create complex geometries, definitely we need an exposure to have the tool or the command to create 3D curves. And in SolidWorks, you have several types of 3D curves to create complex geometries. One, projected curve, and next composite curve, helix and spiral, split line, curve through reference point, and curve through X, Y, Z points. And this command is available in SolidWorks from the insert, curve, and you can here notice the different commands available to create the 3D curves. And now we can see only two commands are inactive since it is able to create only these two type of curves. And if you want to use these curves, definitely there should be an existing geometry. Curves. When you want to create a 3D curve, we need to understand the different commands available in SolidWorks to create this. The first command is split line. Split line tool projects an entity to a surface. It may be a planar, or it may be a non-planar, or it may be a curve. Exactly this curve, if you project on the face, it will divide the face, and you can use the divided face for either drafting, or if you want to offset, you can do the required operation on that face. And now under split line we have three commands. One is projection, silhouette, and intersection. The first topic is projection. In this example you can see the curve is projected on the surface of the steering wheel, and you can notice the curve is projected and these two will be the separate faces, but the solid is not sliced when the face is divided into two. And in this example you can see the cylindrical bottle face is divided into two by using this silhouette option. Next, intersection. Here you can create an intersection curve between a solid face and a plane, or a surface and a solid plane, or the combination of plane and a surface. Let's see how we can do all this in SolidWorks. Initially I will enter SolidWorks by having this hands-on file, and now let's see how we can do this. You can go to insert curve. From here you can retrieve. Now you can see all the commands will be inactive, or I can go to curve. I will use here split. The first option is silhouette. I will use project and select this sketch and select this face. Now the curve is not created. The reason is we need to define the direction. I will reverse this direction and I will click OK. Now you can see the curve is projected and you can see the face is splitted. Now you can use this face for other operation, like I want to offset this face, you can offset this. I'm just giving an idea how you can use this splitted face for different operations. And here you can notice the curve is entirely projected on the revolved surface. So one point you need to understand the length of the curve. The length of the curve you see in this view, you can see it is exactly more than the size of the revolved body. So when you create this, you need to consider this point. The next example is we will use silhouette faces. That is the revolved body. I'll go to curve, split line. Here I will use silhouette. First thing is you need to define the plane, and this is my surface. And you need to select which surface you need and click OK here. The face will be splitted. And now you can use this place, and you can use this face for applying any draft, or you can use for offsetting purpose. And now let us look into one more option in split, that is dividing the face of this clip part. I'll go to split line. Here I'll go for intersection, select this plane or datum plane where you want to make the intersection. I will use this plane as the intersection plane, and the face is this. How many faces you need to project? Select all this, click OK, and now you can see the face has been splitted. This is all about using split line to divide the faces and to create a 3D curve. Project curve is one more type of creating 3D curve, and here we have two options. One is the sketch will be projected on the face, and other, the two sketches will be intersected to create a 3D curve. In this example you can see the curve is projected. In this example you can see the two intersection curve creates a 3D curve. And here if you project any sketch on the face using the command project curve, you will not be able to divide the face. This is my sketch. I'll select my sketch. Not able to select. What I will do, I'll select this sketch. Not okay. I'll select this sketch. I'll go to project, and this is my face. I need to reverse the projection and click OK. Now you can see the sketch has been projected on the face, but this will not be divided. But this can be used as a guide curve or can be used for any other reference geometry creation. Now let's look into the one more project curve, that is sketch on sketch. I need to create a 3D curve after this helix curve. I'll go to project curve, select these two, that is sketch on sketch, select these two, you'll get a curve. And now when you go for any feature geometry creation, these two curves will be separate. So you need to join as a one single curvature. Definitely you need to go to curves. Here you have composite curve. Select this two curves. You can make it as a one single curve. So this will look like one single curve. This is what we called as composite curve. And apart from this, when you want to create a continuous curve on the edges of the part, and that also can be created using composite curve. And that's what I explained here. Curve created from the combination of curves, sketch geometry, or model edges. And let's see one more example on creating a curve through a reference points. Let's see how we can create this. Curve through a reference point. Curve through reference point is useful in creating curve through the reference points. Reference points are derived from the reverse engineering process. In reverse engineering process, we use scanning machine, and that input will be in the form of cloud points. To simulate same like this, that is to simulate the cloud point, I given here 4 points, and using these 4 points we are creating the curves, and based on that curve we can create features, and so that we can complete the remaining process using this reference curve. This is all about creating curve through reference point. The other two interesting features in creating 3D curves in SolidWorks are creating the curve by inputting X, Y, Z points and creating helix and spiral curves. Let's see how we can create this. SolidWorks environment. Here I will go and say create helix and spiral curve. Select this top plane. Create a circle which will define the size of the spring, and I'll make 30 mm, and I will input here as done. And now let's see here you have the callouts. If you want to input the value, you can input here. I'll go and say I need pitch and revolution. Here I will say pitch is 30 mm and revolution I need 5 revolutions. So now you can understand what is pitch and what is revolution. Here in the revolution we are given 5, 1, 2, 3, 4, and with ending of this one here half, and in the top half you can see totally 4 revolutions. And when I say I need height and revolution, here you need to input height, how long you want to create this helical curve. You need to enter the height, and it has to create by clockwise or counterclockwise. And apart from this you can also define taper helix. And when you define taper helix, you know that the taper helix is used in most of the instruments where you require the cushioning effect, where you want to avoid the hard joshing in the component. And you can see normally these type of springs in the walls, where you want to keep the alignment of the component, but if any load is applied on the part, this will exactly take all the load with a small impact on the component. And let's see next one, variable pitch. Variable pitch, as you know, we used to have these type of geometries in our shock absorber. Means the top should have a pitch of so here the pitch is 30 mm at the top, and in the end it is 30, and in the middle I will say one more revolution. I will say 10 mm revolution. I'm sorry, I don't use this height and revolution. I'll go and say height and pitch, so that the control will be easy for us to understand. So control will be easy for you to understand how this exactly works. And here I will say 150, and height is here we have 0, and here I will enter as 20, and the height is 100. It says it should enter more than 150. I'll make it as 200. Now you can see in the height of 200 you can define the specific diameter, and pitch diameter I'll make it as 50. Yes, you can see here we had created the helical curve with variable pitch and variable diameter at the start and at the end. This is how we can create helix curve, and similarly we can create spiral curve. To enter the parameters for the spiral curve, we need to enter pitch, revolution, and start angle. And this 30 mm is exactly the diameter of this, the initial curve what we drawn here. From here it will start, and the pitch is 30 mm. Every spiral curve will have the will have the distance of 30 mm. And here you click OK. Now the spiral curve is created. And now we have one more advantage here. I said that in the previous topic we can create a curve through the points. So that points will be through the reference, or we will input the points and created the curve. But we have the input points in the format of Excel sheet, or you need to input in the format of XYZ. What you need to do is go to curve. Here you have curve through XYZ points. Here you can enter the points one by one. X how much, Y how much, and Z how much. X 20 and Y 30 and Z 50. You can see here a curve will be generated based on this. And once again I will say here I need 5, here I need 10, and here I need 80. You can see here the curve is created based on this input. But we have one more situation. We need to input all the XYZ points which is there in the Excel sheet. What do you need to do? The first thing is you need to import, or you need to copy those XYZ point values to Notepad, and there you can save that file as text file format, and that you can retrieve from here. And you can also save the same file into whatever the points input here, you can save as a curves.sld CRV file format, and you can retrieve wherever you need this. And this is how you can create a curve using XYZ points. And that's all about creating 3D curve in SolidWorks using different commands like split line, project curve, composite curve, curve through XYZ points, curve through reference point, and finally helix and spiral. Draft tappers faces using a specified angle to the selected face in the model. For every component, we required draft elements to be provided to disengage the component from the cavity, and that we called as draft elements. And draft elements to the faces can be given using draft command. And apart from that, you want to taper the vertical faces, we can use draft command. And we have three types of draft in SolidWorks: based on neutral plane, based on parting line, and based on parting line once again, but we create step draft. And this example will show you how the neutral plane is used and draft is applied on the above feature. And in this slide you can see parting line is used to create draft on the face. And here once again, using parting line, we are creating step draft on the faces. Let's see how we can create this in SolidWorks. This is the component, and now I would like to apply draft. I will use 5 degree as the draft angle. This is my face. Here we need to select the top face. If you want to apply face, if you want to apply tapper on this face, you need to select only this face and click OK here. But now you can see the draft is applied on the one face. But if you think the draft should be applied on the entire feature above this neutral plane, you can go and say face propagation as inner face and click OK. Now the face which is above the neutral plane, that will be given draft. And when you say face propagation as outer faces, and the bottom face will be applied draft. And we have one more advantage here, that is if you have tangent edges. Here I have an edge which is having a sharp corner. I will making as a blend. Now I'll go and draft this face. The neutral plane, once again this is my plane, and the face you need to select the entire face, not required. You can go and say tangent along tangent and select one face and click OK. The tangent faces will be selected for the draft. And this is all about draft based on the neutral plane. Now let's go to the next topic, parting line. This model, you can see there is a face split created here, and this face split is created using split line command. And we are using this line, and using this line we had splitted this entire solid body. That is, we had just splitted the face. We divided the face, not the whole solid body, only the face of the solid body. And let's go to the command draft. Here I will use parting line, and the direction of pulling is this way. Parting line is, this is my parting line. You can select once again along tangent, or I will go and say this one and this. I will select manually one by one, and we can apply the draft angle. And at last this edge, and I will say 5 degree. Let's see the preview. Now you can see draft is applied on this faces. This is how you can create draft based on the parting line. I'll make it as 10 degree. Let's see one more difference on this. You can see the above geometry, that is above parting line, the faces are drafted. And you can flip this direction and you can apply draft on the negative direction. This is how we can apply draft on the faces using parting line. The next draft is step draft. Similarly, we had created one more component, and we had divided the face using split line, and here this sketch is dividing this face. Let's see how we can create this. Go to draft, step draft, pull direction. I need to define the direction. I'll take this plane. No, I'll take this top plane. And parting line is, this is my parting line. I'll take this parting line and I will say degree is 5 degree, and let's see the preview. And here you can see step draft. And now let's make this draft angle to be 10 so that we can understand the difference between perpendicular step and taper step. Now let's see in the top view. In this top view, you can see the difference. You notice here. Now I will see the preview. You can see the edges. This edge will be having perpendicular step. Now I'll go and say perpendicular steps. Now you can see this edge, once again it is made exactly perpendicular to this face. I will click OK here, and let's see the difference here. Here you can see the drafted faces. I'll go and say tapered faces and click OK. Now you can see the difference. This face will not be exactly normal to this condition, but when I say here as option perpendicular steps, you can see here this edge will be always parallel to this face. This is what we call as taper step and perpendicular steps, and this is all about draft in SolidWorks. Hole, it's one more applied feature in SolidWorks. And we have two type of holes in SolidWorks. One is simple hole and another hole wizard. Simple hole will place the hole and you can set a depth, but it creates a cylindrical hole with tapper on the face. If needed, you can apply tapper, that is, you can apply draft on the cylindrical face. And hole wizard will allow you to place the hole with countersink, counter bore, and then cosmetic thread, that is tapered hole, you can place it. Let's see how we can do this in SolidWorks. This is my component. I would like to locate hole on this face. What I need to do is insert, feature, hole. We have simple hole, and now it is asking for the face. Let us select this face. Now you can see we are not able to position this hole, but it has taken its own location. Now you need to define the diameter and the depth, everything here. Once you define this, if required, you can apply draft and click OK here. And once you located this, you need to go to the sketch and edit the sketch, and now you can constrain this with respect to the edges. And this is how you can locate the simple hole. But when you go to hole wizard, it's different. You can define before inserting the hole into the feature. Go to wizard, and once you click the wizard, you will have two tabs. One is type and one is position. Before you position this, you can choose which type of hole you would like to place on the component. I would like to take straight tap, or I would like to take counter bore. Whatever the type of hole you choose, everything will have the specification, that is standard specification, and you can also customize those specification. When you select counter bore, you will have different standards and what type of bore you want to keep, and you can select options like head clearance and end conditions. And now what I will do, I will take this straight tap, and moreover I would like to have a cosmetic thread. I'll choose this icon, and here you can see the thread is given as dimension as blind into 2 into dia, and the thread class is 2B. And once we decided all this, you can go to position, and here you can, using 3D sketch, you can position this. When you are positioning this, you can see here you will be able to get exactly center point of the existing edge. And you need to locate one more circle, it is one more hole. Yeah, you can locate this. How many hole you required, you can locate randomly. And once you finish this, you can right click and you can get dimension. From here to here, I need a distance of 25. And is it possible to apply constraints? Yeah, it is possible. Select these two center points and you can say it should be along X. Now you can see both are in parallel condition. That is, both are in coincident, the same plane. Now click OK here. And this is how you can create taper hole or countersink bore or counter bore hole in SolidWorks. So using this hole command, you can create either simple hole or hole wizard, but preferable way is going and creating the hole using hole wizard. Shell command is used to scoop the material from the solid body, thereby creating thin walls inside. That means we are converting the solid body into thin feature. And once you complete this, you can also apply multiple thickness on the faces. And let's see how we can create this in SolidWorks. Here we created a shell which is not fully completed. I would like to apply shell on this cap so that this solid body will be converted as a thin feature. Now the thickness is 2 mm. Show the preview and click OK. Now thickness is applied, means the shell has been applied. You can understand this by clicking this icon section view, and you can see the shell created inside. Now I need to remove some of the faces to accommodate this component into another component. I will go and say once again show preview. Here this faces I need to remove. and I'll click OK here. Now you can see the face is removed. And there is one more need. Can I apply a different thickness for this face? Go to shell command. Here you have multi thickness. I'll enter as 5 mm and select this face and click OK. Now let's go to the section view, and here you can see this surface will have 2 mm, only this face will have 5 mm. This is how we can apply the equal thickness and also different thickness for the specified surface. Rib. Rib is a special type of extrude feature which is created from open or closed sketch contours. And this is especially added for a component to add strength for the component. If you look this component, if you make this vertical feature and horizontal feature, if any load is applied in this direction, definitely you will have a lot of concentration on this area. To avoid this, definitely we need to add a rib which will strengthen the geometry. And now let's see how we can create this using SolidWorks. This is my machine component, and I had created a curve over here. And now let's retrieve the command insert feature. We have rib. Select this already created sketch, and now we have thickness. You want to apply on the one side, on the both the sides. I'll make it as on the one side, on the other side, or it should be symmetrically distributed. And here we have extrusion direction. One is parallel to sketch and one is normal to sketch. Now we are using parallel to sketch. In the next tutorial we will see normal to sketch. Once you applied this, if you decide you want to create a rib with a draft, you can also apply draft. Here you can enter degree as 2 degree and click OK here. Draft will be created on the rib feature. This is how you can create a rib feature in SolidWorks. If you zoom here, you can see this face is drafted at an angle. And next one is, we will understand how this extrusion direction works out. I'll go to the next slide. Here you can see thickness influence, and also we need to understand how this extrude direction work out, and the linear and natural, how it behaves for an open loop. Now let's go to the plate. Here we have a plate, and I need to create a rib using this open profile, but the extrusion direction will be normal to the sketch. Let's go to the rib. I'll select this sketch, and now it is showing parallel to the sketch. I can make it as thickness as 2 mm, and now let's see the difference. If you create this, I'll make this way. Now I'll just see the first in this view and flip inside, and now if I use preview, you can see here how the rib is created. But I require this has to be created normal to sketch. I'll go to normal to sketch, and let's use linear as the direction and see the preview. This is linear direction, and you can select natural, and let's see the preview. You can see this is what? Natural. So it will not be able to extend, it will leave as it is, how the line will be extended. That's what we call as natural. And let's see one more complicated sketch. We have number of intersections. Can we create rib on this lines? Of course, this is also possible in rib. Go to rib. I can select the sketch. You can see everything is set in one single step. Enter 2 as a thickness. Now the option is selected as normal to sketch. If required, you can apply the angle here, and done. Now you can see the rib is created on this face. And there is one more example to show the draft influence. I'll go and choose one more placing block. Here I need to create a rib using this open profile, and here I need to apply draft. We have two options. One is at sketch plane and at wall interface. Now I will enter 10 mm. Let's look in one direction so that we can able to understand the application of thickness on the face. 10 mm, I will see the preview. Not able to see this. I will click OK here. We have chosen the option as add sketch. Click OK here. Now skip this in this direction. I think we can orient in this direction. Now once again I'll go and see in this area. Now I'll apply preview. Now we can see draft is applied, the thickness you can see where it is applied, and the faces you can see it is going inside. Now once again I'll go and say draft should be applied exactly on the wall interface, and let's see the preview. You can see here it is applied on the wall interface. Means if you see in this, if you click OK, you can see here the draft is applied on the interface of the face. That is from this condition, from this area you can see. And let's measure the thickness 10 mm where it is applied. I'll go to evaluate. Here I will use measure, and this is first a vertex and second vertex, and this is what distance 9.61, but we had applied 10 mm thickness. And let's see here whether it is applied or not. Go to measure. I'll select this point and this point, and here if you measure this you'll be able to see the thickness. Now it says 10.34. so this make us understand we are using at wall interface. And let's see at sketch plane, and we'll measure the thickness applied here. And I'll click OK here. I'll go to measure, I'll select this end and this vertex. Now you can see 10 mm. This is what at sketch plane. And now if I measure on these two ends, definitely the thickness will be varying. Once again I'll do it, this vertex and this vertex. Now you can see the thickness is 10.73. so here you need to understand, if you apply the thickness type as at sketch plane, you'll be getting 10 mm thickness exactly on this sketch plane, that is on this face. And if you use at wall interface, where the wall is getting interface, there from there the draft will be created. And that's all about rib in SolidWorks. To avoid monotonous job, to avoid repetitive tasks in SolidWorks, we have different type of patterns. The pattern exactly repeats the feature in a linear fashion or a circular fashion, or it can be based on a curve driven, or it can be based on the location what you choose, or it can be based on the inputting the values from where it has to locate in the X, Y and Z, and you can fill the area where you want to place. And that's what we say as linear pattern, circular, sketch driven, curve driven, table driven, fill pattern, and at last mirror. Let us discuss each pattern in detail. Linear pattern. Linear pattern in SolidWorks is useful to create multiple copies of a feature or a set of faces on an imported body or a solid body or a surface. And you can also skip the instances which you don't require when you are making multiple copies, as shown in this figure. And in this figure you can see a connector is made multiple copies using bodies to pattern. Let's see how we can do this in SolidWorks. Here this is a plate and we have a hole located on this side. I want to make multiple copies of this. Go to feature, go to linear pattern. Here direction you need to mention this way, and second direction this way, and the feature is this hole. Once you completed, you can see the hole is located. I don't require 60 mm, the distance should be 30 mm. And when you create this, I need this 50 also to be 45. But when you create this, you can feel this hole is not exactly located, means we don't require the hole on the slot as it is engaged in the other component. So what I can do is I can go to instance to skip. I can skip these two holes, and if you require this hole, you can also skip this. And click OK here. You can see the features created. The pattern is creating linear fashion design, but we need one more requirement, that is I don't require all the holes to be shown. Now every hole is shown here. I don't require all the pattern to be shown. When you take solar panel, you have number of slots, and in that slot I don't require to represent all the slots which can make the viewer to view the model and understand it. So I need to show only the vertical orientation and horizontal orientation of the feature. For this you can use pattern seed only and click OK. You will able to see only the vertical and horizontal copies. And there are other interesting options available in linear pattern. Let us look into this. Vary sketch and propagate visual properties. Let's go into SolidWorks. Here you have a cut on this solid body. You need to make a linear pattern of this direction. Before that, first I will select this extrude cut feature, and the direction is the 6 mm, and I need a copy of 6. The distance I'll make it as 20, and before creating it I will uncheck this vary sketch and geometry pattern and I'll click OK here. Now you can see the extrude cut is copied as it is without following its geometric nature. I'll go and say vary sketch and click OK here. Now you can see the sketches, that is the feature is created in a linear direction, but it is varying. But this can be achieved only if the sketch is fully defined like this. Means you have a dimension referring with this edge, and you are given dimension for this, and between these two edges we have parallel constraint, and we need to dimension the distance between this line segment and this edge. Only then you can get this vary sketch pattern in linear pattern. And now let's look into one more option, that is visual properties. Propagate visual properties. This is a partially completed solar panel, not exactly, but let us see how we can populate this slot on this face. I'll go to linear pattern. Here direction is this way and direction is this way, second direction, and features is this, and now I need to increase the distance between this, and second direction I need this. If I uncheck this and I'll click OK, now you can see the same color is not carried on all the features, but I need all the visual properties has to be carried to the children's. You need to go and say propagate visual properties and click OK here. Now you can see the difference. This is what propagate visual properties. And there is one more thing we are left, that is solid bodies creating in a linear direction. This is a connector. I need to make multiple copies of the solid body. Go to linear pattern, select this direction 1 and direction 2, and here bodies to pattern, select this body, and the one most important thing is you need to give a distance between two patterns, and once you complete this, click OK here, and now you'll be able to see multiple copies of this solid body. And this is how you can create linear pattern in SolidWorks. And we have one more option to be understood in linear pattern, that is geometry pattern. What exactly this geometry pattern means? You can see here, if I make a multiple copy of this slot, the end condition of this slot is offset from the surface. So when you select geometry pattern, you can see the difference over here, and when you check this geometry pattern, you can see the difference of the slot created in this part. Let's see how we can do this in SolidWorks. I'll go to geometry pattern. Here we have a slot here, and let's see in the front view, and we need to understand how this feature has been created. I'll go to cut extrude, edit feature, and here we are given offset from the face, and the face is the bottom face, and we are given a distance of 20 mm. Once I complete this, now let us go for the linear pattern. Direction is this way, and features this feature, and I will make distance between this as 60 mm, and here I will check this geometry pattern. I'll click OK here. You can see how the end condition of the multiple feature is created, and when I uncheck this geometry pattern, you can see how the end condition will be created for this linear pattern. This is all about linear pattern in SolidWorks. Circular pattern. Circular pattern will help us to arrange the selected feature, the selected body, to rotate about an axis and create multiple copies. And here you can see an pulley wheel where you can see the spokes are placed on a circular fashion. Now let's see how we can create this. Let's go and choose circular pattern from here. The direction is you can select either the circular edge and you can go and select the feature, or if you want to require, if you require to select the axis, you can go and say view temporary axis and this axis can be selected. From there you can do it. The options which you've seen in linear pattern, the same will be here, like faces to pattern, bodies to pattern, and instance to skip. Here you can use equal spacing, or you can define the spacing specifically between each instance. This is all about circular pattern. Sketch driven pattern. In this pattern, we will define the reference point using sketch, and those reference point will be used for locating the features. And here you need to understand which is reference sketch. This is the reference sketch, the points which you create in the sketch mode, and centroid and use another point. This two will give you the option of locating the feature on the points where you need to locate it. Let's see how we can do this in graphical user interface of SolidWorks. I'll go for first this cut, and I will say I need to make sketch driven pattern, and here the first point is you need to locate the points, and once you locate this, you can see instantly it will place all the cut features on the reference point. But I don't want to locate like this. I would locate using now it is located actually using centroid. Now I will go and say selected point, and here if I select this vertex, exactly you can see all the points will be used to locate the vertex of the selected point. And this is how we can do sketch driven pattern. And when you go for the hole, similarly we can do the same. Circular sketch driven pattern, select this curves, and you can see here holes are located, and click OK to create this. This is how we can create sketch driven pattern in SolidWorks. Curve driven pattern. In curve driven pattern, the feature is created multiple copies along a selected planar or 3D curve, and there are different alignment methods, and there are different curve methods, and also we have a different method of placing the features based on the face we select. In this slide you can see it is located on the elliptical path, and here you can see the feature is located on the cylindrical face with the face selected as the normal direction. And let's see how we can do this in SolidWorks. The first one is I want to make multiple copies of this hole along an elliptical path. Go to curve driven pattern, select this direction, and the features to pattern is this feature. Now you can see the hole copied along the path. You can unselect this equal spacing, and you can give the manual spacing between each hole. And the same like you have faces to pattern, bodies to pattern, instance to skip, and apart from that you have different options here. And now you can click OK to complete this process. Now let's see the other options available here, that is curve driven pattern using curve method. I'll go and select this cut extrude and go to curve driven pattern, and here I will choose direction as this edge, and we need to change the direction. And now the feature is cut extrude. You can see the difference here, the change in the orientation. Now what I will do, I will use tangent curve. Now it's the alignment method is tangent to curve. When I choose align to seed, you can see the orientation of the feature will be same. But when I make a tangent curve, it will make tangent to this selected path. And I will show you one more difference for the curve method. If I choose this as the feature, and now the method is transform curve. If I use offset curve, you can see exactly it is offset from the curve. And this is how you can create curve driven pattern in SolidWorks. And there is one more interesting feature here, creating a curve driven pattern based on the normal to the face. That is the face what we select, accordingly the pattern will be created. I will select this feature. I will go to curve driven pattern, and here my direction is this 3D helical path, and the direction I need to skip. I need to change here. I will make equal spacing, and here feature cannot be selected. I will clear this and I will make bodies to pattern because it is not united. So I'll select this body, and now we'll click this direction, and here once again I need to say line to seed and faces. This is on my face, and let's do one thing. I will make once again tangent to curve and click OK. And now we can see the curve driven pattern based on the face normal direction. It is located on the cylindrical face. This is how you can create curve driven pattern in SolidWorks. Table driven pattern. Table driven pattern is especially used to create whole tables on the machine tables, since all the whole will be dimension from one single origin. And that's why when you create table driven pattern, it is preferable to place a coordinate system on a specific corner where you want to locate the whole. And there is one more pattern which is so interesting in SolidWorks, fill pattern. In fill pattern we have different type of styles and predefined cut that you can make on the defined feature. Let us do these two patterns in SolidWorks. Now this is the machine block, this is machine table, not fully completed. Now let's see how we can place this hole. Select this hole, go to pattern. Here we have table driven pattern. Once you selected this, you need to say which is my coordinate system. This is my coordinate system. Now we have defined the x and y direction. The default value is shown here. I'll make one more value as 50, and in the y direction I'll make it as 60. Now you can see the hole is created. I'll make one more dimension 150, and this is 250, but 250 it is going beyond this. I'll make it as 100. Similarly, you can make n number of holes, but you cannot change the diameter of the hole or size of the hole. Only the location can be given as an input, and you can save it as an format as a pattern table, or you have the predefined pattern as a template. You can go and browse from the sample design library. Click OK here, and now you can see the hole is located using table driven pattern. The next one is fill pattern. Fill pattern, as I told, it's one of the interesting feature in SolidWorks. Let's go and see what is the interesting feature. Go to fill pattern, and the boundary is this, and the direction is this. This is my direction, and I'll flip this, and now let's see, I want to create a seed cut, and let's see the flip shape direction. But once we need to do is I need to say the direction, not this one. I will use direction as this axis. I will take this as the direction, and we need to show this, and now we will select this as a direction. Now we can see the features, that is seed cut has been created. We have circular seed cut, square, polygon shape, you can apply whatever the shape you need, and the pattern, what type of pattern you want to apply here. You want to use perforation or you want to use circular, which type you need, you can select from here. Once you create this, you can control the distance between each pattern from this dialog box. Target spacing, instance per loop, and apart from this you have one more advantage, selected features. If you have any predefined features, that feature you can use so that it will be patterned in this layout. And this is what all about fill pattern in SolidWorks. And as of now, we had seen different patterns in SolidWorks, starting with linear, circular, sketch driven, curve driven, and table driven, and fill pattern. Now there is one more thing we need to understand, mirror command. Let's see in the later session. Mirror. As we had seen, a mirror command in Sketcher environment, we used to copy the sketch entities on one side to the other side by using a center axis. The same we are going to do in part environment, where we are going to mirror a feature about a plane. Let's see how we can do this in SolidWorks. And when we are mirroring it, we can choose either one single body, or you can choose couple of faces, or you can choose a single feature. I'll go to SolidWorks environment. Here I need to mirror this rib. I'll go to mirror. Here the plane is this is my mirroring plane, and here features to mirror, select this feature and click OK to complete this process, and check whether once you completed a mirror command, whether all this are in one single body or not. If this is not single body, then your geometry will not be parametrically controlled. And that's all about creating a number of copies and avoiding the repetitive task. Different type of pattern and mirror will create multiple copies of a solid body or a selected face or a surface body or a feature. Advanced modeling tools. Advanced modeling tools in SolidWorks is helping every user to create most complicated geometries as simple as possible. As an example, here you can see the lamp body, and this lamp body you have to create some stylish surface. You need to apply some bend curvature in this face, and if you want to do like this, definitely you cannot go with sketch based approach. And this image you can see we need some smooth dome on the faces, like creating a smooth transition like this, smooth a bump on the face. And this you cannot create using the command like loft, or you cannot create with applied features like round. And there is one more option, you can also bend, stretch, and then you can also twist the whole model according to your requirement. And these three operations we are going to see in SolidWorks. We're going to see right now these three commands. At the start with the first one, dome. This is a partially completed handle of a gadget. I would like to apply dome on the faces. Go to dome, select the face, and here you can see the value is 10, and you can see the dome is created, but this dome is like hemispherical ball. I can use elliptical dome to make it as a elliptical shape on this face. This is one, and I want to apply on this face, on this face, and on this split face, and I'll reduce the value as 2 mm and click OK here. Now you can see the dome is applied on this faces, and the dome can be applied either you can add material. If you reverse this, you can create inside, that is removing the material. Both the way you can do it. This is all about creating dome on the a splitter face or on the face of a feature. Now let's see how we can create freeform faces on the lamp model. This is the lamp model. Now I had splitted the face into two. Let's see how we can create a free surface, that is your rough surface where you can see many curvature on this surface. Now I'll go to insert feature, I'll go to freeform, and from here you can choose freeform. The face is this is my face. Once you selected the face, you need to select right click, or you go to add curves and add the curves in this direction. You need to change the direction, use tab and add this grid points, grid lines. This grid line is helpful in adding the points so that you will have the advantage of dragging the face. I'll go and say this face I want to create a point here. Right click, and once you complete this, go to the add curve. You need to add curves, we can do it, or I can go to add points. I will add the points on this curve, and then I will select this point and I'll drag this. I'll select this point and you can drag this face as per the requirement. And you can see here we are just about to drag this. I don't want to drag this much. I will reduce this to up to here, but we are doing in a rough way. So what I will do here, I will just drag in this way, and this line has to be dragged in this way. So here you need to understand the face we are selecting here is modified using this dragging points, and this dragging point is created using freeform. And once when you're creating this, you can control the orientation of the triad using the orientation given here. It should be surface based or should be global. I'll use surface based. Now I will drag this. Now you can see exactly we are dragging this according to our requirement, and the triad is oriented normal to the surface. And this point I need to drag. I'll select and drag up to here, and I'll click OK. And now you can see the freeform is created on the face, and you can see there is a different type of shape on this face, and here you can type the company logo by using the Photoshop, or you can use PhotoWorks and you can apply the logo on the face using PhotoView 360, or you can use PhotoWorks and you can do the decal applied on the face. And this is all about creating freeform in SolidWorks. The next advanced modeling command is flex. In flex, you will be able to do bending, twisting, and also stretching, tapering, or all this operation you can do it in flex command. Bending, twisting, tapering, stretching. I'll select this body, and now you can do bending for this model, or you need to apply taper. You can apply taper for this, or you can also twist this. I can apply the twist angle, and you can see the twist is applied for this model. So like this you can create consumer products which is more attractive in nature by having some twist on the whole geometry. You can look some of the deodorant spray bottles. Now in this pump cover, what I need to do is I need to stretch this entire geometry. I'll go to stretching, and in the stretching, first thing is I would like to locate the point so that I can control the geometry. Here this geometry, the plane should be here, and the secondary plane should be on this point. And now if we start to input the value, we can see only this geometry, it is beyond this point, only that geometry will be fixed, the remaining geometry will be stretched. And here you can see the value of the triad, where it is located. If you want to locate, you can relocate this using coordinates. We can change the orientation of the triad, because using a triad only we are orienting and we are stretching the model and we are twisting and we are applying taper for this. And this is all about applying flex to a pump cover. The next advanced modeling tools in SolidWorks is deform. deform, you have three types. One is point deformation, and one is curve to curve deformation, and the other you are going to push a body on the other body. And this tool will exactly alter the complex surfaces or solid models will in a local area, or it can be globally. And this will be with the help of Sketch or without the help of Sketch. And let's see a overall view on this different deform types. The first one is deform point. Deform point is the simplest way to alter the complex shapes. There is a flat solid and it is deformed using point, and you can see the deformed component here. Here you are going to choose only one single point or edge on vertex, and then you are going to apply the distance and the spherical radius which will control the whole deformation. The next, curve to curve. Curve to curve is helpful in deforming the part by selecting the initial curve and the target curve. So the initial curve will take the shape of the target curve, and here you can see the strip which is being deformed to the selected curve, and this is the deformation applied on the strip. And next, surface push. Surface push is one more advanced modeling tool under deformation, where you will be able to push the solid body on the surface and you'll get the shape. And for this we need triad to be located exactly where you want to position the solid body. Now let's see all this in SolidWorks. The first one is curve to curve deformation. Go to insert. Before that, you understand how this geometry is created. This is a simple 2D sketch, and before that I had created as extrude, and this extrude feature top surface is splitted using split line command using a sketch. And now we are going to deform this. Go to insert, feature, deform. Here I will use curve to curve. My first curve is this, and the second curve is this target curve is this one. We need to select the whole curve so that we can see the deformation here. Select the whole curve, and now here you need to fix which face or which edge. I will use this fix faces. This is my face. Now you can see the deformation starts from here, and this is additional faces. If you want to deform, you can select the faces where you want to additionally deform it, and here one single body you can select, and you can use uniform so that the deformation will be uniform. And this is all about creating deformation by selecting the initial curve and the target curve. And you have sets over here to define multiple curves to be targeted on the multiple target curves. That is, you can select two different curves and you can select two different target curves, and the shape will be modified. This is curve to curve deformation. Now it is not able to process. What I will do is I will deform. I will uncheck this uniform, and now let's see. But initial curve does not touch the fixed geometry. So what I will do is I will deselect this fixed geometry and I'll click OK here. Now you can see the deformation is created based on the curve to curve. And the next example is deform point. Let's see how we can do this. This is a component, and in this component I need to deform based on the point. That is, we need to modify using the feature called as point. We need to select the point, and the next we need to give direction. I will use top lens direction, and here you can see 10 mm, and this is a 10 mm given for this this bump. You can see the icon which is defining this 10 mm, and this is the spherical ball which is making the shape. If you enter as 80 here, you can see the spherical ball is located here, but you can see there is no deformation on this face, on this geometry. If I make it as once again 50, you can see deformation. I'll make it as 500, you can see a deformation, and we'll make it as 250. You can see the deformation, not able to see here. We'll make it as once again 125. And this is how you can modify the geometry using point deformation. And now let's go and learn about surface push. I'll go to the surface push, and here we need to push the solid body into this face. Go to insert, feature, deform. Here surface push, direction is top plane, normal to this, and the deformation area which has to be deformed, this is my face. And which body, first I will choose ellipse as a default shape, which I need to emboss on this face. Given this shape, and now we need to relocate this. Before that, I would take the select body option, and I will choose this body I need to project. And now you can see here, here we need to uncheck this, and the option is, this is bodies to deformed, and this is the face to deform. I'll uncheck this. What I will do is, first I will go and say this is the body which I need to emboss, and the body is this, I want to deform it. And now we can see the deformation when you drag this triad on this face. We need to drag it slowly so that we can see the deformation. I will drag once again on the upward direction. Now we are moving this. We'll just move on this direction up to this much, but still we are able to move only in the increment of 5, 10. What I will do here, I'll go and say this should be incremented in the distance of 30. Now we got increment 30, and next this should be 60. It is processing right now. Now you can see the deformation shape created on this face. Now click OK here. You can see the deformation, that is the solid body embossed on the surface. But here I don't require the solid body. I need to use the predefined shape. Here go and say polygon or rectangle or sphere. I'll go and say sphere, and you need to enter the values for the sphere shape, how you need to create this, and what is the size of the sphere. Once again I will relocate this sphere by entering the values here. I'll make it as -20. Now it is relocated to, okay, 20 is not able to move in this direction. I'll make it as okay. Let's see the deformation. Let's kick this done here, because it takes a long time to regenerate. So click OK here and understand how the predefined shape will also deform the selected face. And that's all about deformation command in SolidWorks. Indent. This is one more advanced modeling command, and this is helpful in creating packaging materials, where you will be able to create a protrusion or a pocket between the target body and the tool body. And here you can have a combination of surface and solid and a solid, or you can emboss the solid on a surface. And the components which you require for packaging, for stamping, molds and press fit for machineries, all these components can be designed using indent. And this example will give you an overview on the indent. This is a U-clamp, and you need to create like this cover for the U-clamp. So we create a surface, and this is indent on this surface. Let's see how we can use it for the application. Now we have two bodies, one is solid body and one is surface. You can see here, this is surface and this is solid. And now I'll go to insert, feature. Here I will choose indent. One is target body and one is tool body. I will use target body as this and tool body as this solid body. Once you selected this, you need to say which one you want to keep. You want to keep on the upside or you want to keep on the bottom side. You have to choose this, and once you've chosen this, you need to say offset distance if required. Offset is nothing but if you enter this distance as 0.5, you can see it will have an offset. and there you will have the, but obviously here we need an offset, so because it is in package and packaging sheet, I'll give in a 0.25 as the offset distance and click OK here. Now you can see it is embossed in the sheet. You need to hide the solid body so that you can see this embossed sheet. This is how you can create indent on the sheet by embossing the solid body as a tool body and target as the plain sheet. And let's see one more application example here. In this example, you need to understand how this is created. This is a separate solid body, this is a separate thin feature, and this is a separate feature, and these two become one single part. Right now it is two different parts, and let's see how this is exactly in the model when it is splitted. I'll go to insert feature. Here we have move copy. I'll drag this so that we can understand how this geometry is created. So here we have, this is one feature, this is one part, this is one solid body, and this is one more solid body. Now I need to create a provision to accommodate this part on this component. What I will do here is I'll go to feature indent. I need to indent, this is my target and this is my tool body. Once you created this, definitely we require some clearance. So what I will do is I will use cut. Now you will have a cut on this face, or you can use without cut, we can emboss this. I will make thickness as 0. We cannot enter 0, I will make it as 1 mm. Still it is not able to create. I'll make it as this as 0.25, and I'll make it as 0.1 so that a geometry will be created without much of the complication. Now we had given thickness as 1, and here the thickness 1 mm, you can notice here how it is applied. I'll here make it as 0.1 mm. You can see the thickness applied over here, and click OK so that you can understand how it is exactly created. I will use remove. I need to make the inside one and select OK here. Now this is embossed on this face, and now if you go and say feature move copy and select this face and move in this direction, you can see this tool body will be embossed on this face. And 1 mm thickness is nothing but the thickness applied on this face, and the clearance, as we had seen in the last command, clearance, how it will be defined. And this is all about indent in SolidWorks, and this will helpful in creating most of the packaging materials and also reduce the time taken in creating two different parts in one single file, and import this part to the next file by right clicking here and use insert into new part, and there you can insert a single part and you can start to create core and cavity for that. And that's all about indent in SolidWorks. As we had discussed earlier, SolidWorks has process specific feature. We are going to see those process specific feature. Fastening feature, which is specifically used for plastic and sheet metal parts. It will exactly reduce the time required in creating these type of features, because when you want to create these features, definitely you need to create sketch. Based on that, you need to remove the material or add the material, which will once again complicate and increase the time in designing the part. So to target this and to avoid the time required to do this, we have process specific features like mounting boss, snap hook groove, vent, and lip and groove. Let's see how we can locate all this in this component. The first one is fastening features. We have mounting boss. Mounting boss, you have two type of mounting boss. One is male part and one is female part. Now we are going to create the first basic one. Select the location here. Here we are not using any specific location. We need to locate first, or we can use the circular edge, and if you select this edge with respect to that, it will create concentric. Now I need to locate roughly on this face, so I'll select the face. Now the mounting boss is located, and the parameter for this we can control from here. The distance, the diameter, angle, the length, height, the direction for the fin, and the number of fins you require, so that you can add strength, and you want to have hole on the top or pin on the top. And once you complete this, click OK here. Now the mounting boss is located, and you want to exactly constrain this. Open this, we have 3D sketch, edit this, and once again you can go and use smart dimension, and you can refer with respect to this edge, and you can do dimension for this. This is how you can locate mounting boss on this plastic component. And now let's go to the next fastening feature, snap hook. Snap hook and snap hook groove, we need two different bodies. First, I will create snap hook on this body. What I will do is I will select this edge where I need to locate this, and now we need to define the direction. This is my vertical direction, and change this in the face which direction it has to look. I will select this plane, means which plane. I will select this right plane, and we have to reverse this. Now you can see snap hook is located on this face. Once again, you can control the parameters from this property manager, and once you define all this, I will go and say here what I need to do is I need to say width is enough to create the groove. I hope this will be enough. So click OK here, and now we need to add snap hook groove. So I'll activate the above geometry. That is, I need to activate one more geometry available here. That is this geometry, this solid body. Now let's go to the insert feature, fastening feature. Here I'll go for snap hook groove. I'll select the snap hook. We need to go for wireframe display, or I will go to this feature manager, select the snap groove, and the next body is here. I need to create the groove. You can see the preview how it will create here. You can just click OK, or you can give the offset distance. Now I don't require any offset distance. I understood how it is created. Click OK here. Now the snap was created. Let's go for the section view, and now I'll drag this and I'll make you understand how the snap was created. So here you can see snap hook and snap hook groove. And now let's see how we can create vent hole on this model. I will delete the snap hook and also delete the mounting boss, so that I can avoid the regeneration time. And I don't require sectional view, and also don't require this top model, that is a top solid body. Using this sketch, I'm going to create vent hole. Go to insert, fastening feature, vent. Here the boundary is this, and I need to select ribs. These are my ribs, and once I selected the ribs, we need to select one more thing, that is spars. These are my spars. You can select the spars, and for this rib and spar you can enter the parameters here. The thickness D1 and D2, the width and length, that is the thickness and the width, and you can also define fill boundary, that is this end should be filled. You can do it. Select this one, and this circle will be filled to create the fill in boundary. Once you define all this, you can understand the various parameters given here by viewing in a proper direction, so that you can understand how this is placed. And here you can see this width, that is this width I want to change. You go to the ribs. Here I'll make it as 1 mm as 5 mm. You can see the difference here. This is how you can control the whole vent created on this part. And once you complete this, the next one more feature we need to understand, that is lip groove. There's one more interesting feature for aligning two components. At first I would activate the top solid body, and now let's go to the insert feature, fastening feature, lip and groove, and I'll select this top solid, and I will select the bottom solid. Before that, I would like to say here we need to select the body where you want to create groove. I want to create the groove on the bottom wing. And next one is lip. I want to create a lip. Sorry, you want to define the edges where you want to create the groove. I'll go and say this edge and tangent propagation, and let's go and select one more thing, that is lip. That is, we had selected first one, that is groove, and we need to select one more thing. This is this model, and that is here we had to select where to create groove, and here we need to select where to create one more thing. First, I would like to say groove is located here, and click OK. Now we need to correct one more thing, that is edge has to be selected exactly. I'll go and select all these edges, and direction is this way. Now we are located groove, and click OK here. Before that, let's give OK here, and now you can see lip and groove has been created, but as of now we had given only groove. We need to create lip. Let's see how we can create a lip and groove in the next session. Let us see how we can create lip and groove for the same solid body using lip and groove command. Go to Insert, Fastening Feature, Lip Groove. First, we need to select where we need to place groove and where we need to place lip. Once you define that, you need to say where this groove has to be located and on the which edge. So now the groove has been located, and the next one is lip. Now the top body is enabled. We need to select this top face and also this edge for locating this lip. And the parameter for controlling this lip is located on this parameter dialog box. You can change one by one, and you can see the difference. And moreover, it is user friendly to understand which value is defining which size by seeing this preview available here. Once you created it, just give OK here, and now a lip and groove is created using the command. Let's see in the sectional view how this has been created. Click OK. Now you can see the lip and groove creation. And one more thing, if you move this still, you can understand how it is created on this. Go to move and copy, select this using triad. I'll just locate over here, and you can see here how this has been created on this component. This is how you can create lip and groove, or if you need to create only groove or only lip, as we had seen the last session, the same, it was done in different way. And it's all about creating fastening features in SolidWorks, which is avoiding the repeated features created in plastic components by using the ready-made shapes like mounting bars, snap hook groove, and you can use vent to create on the plastic components. Next, working with views. As a default, we have these predefined views: orthographic views, trimetric, isometric, and dimetric. But customer will ask you different type of view where they can understand the inside geometry of the part. Now every time we cannot show them by orienting manually. Now we need to save the specific view of a component. How can I do this? Let's see how we can do this in SolidWorks. This is a blow dryer cover, and now I need isometric view, trimetric view, dimetric view, but I need to view this inside view, and this should be saved with a name here. I hope you know that how to retrieve this orientation dialog box. We can use spacebar. If I close this, I can use spacebar to retrieve this dialog box, and you can pin this to permanently stick this dialog box on this graphical area. Now the first one is you orient the view which direction you need, and click the icon here, new view, and enter the name inside view and click OK here. Now the view has been created. Let's go to the isometric view, and now if I select inside view, we can see the created view is saved in this dialog box. And this is how we can create the user-defined view, and the same view will be useful for us to show the product to the customer, and also to retrieve the different views in the detailing also. It's all about creating views and manipulating it. Library feature in SolidWorks will help the user to create user-defined feature in one separate location, and you can retrieve the feature or the sketch multiple times for the future creation. Company logos or predefined keyways or predefined spline keyways, you can save it as an library feature, and that you can retrieve. This is what it is shown here. Let's see how we can do this in SolidWorks. This is my shaft. I have a spline keyway, and this I should make it as a library feature so that I can use it in this component. The first task is we need to select this cut feature, and before that I would go to configuration, right click and make it as add to library, and from here we need to choose the cut feature. This way we can do it, or one more way is we have to open this task pan and make this to be auto show. That is, you need to pin this and after that we need to choose add to library. Select this and select this library and choose add to library. From here, items to add, I need to select this cut extrude, and I'll give a description if you need, and click OK here. And now this will be saved in this design, in this library feature. This library feature path you need to define by using tools and go to options. Here from file location, from here you need to go to design library. Here you need to, using add, you need to add the location where you want to save this. Similarly, I added this path. In this path we have saved this spline, this keyway spline. Now let's see how we can retrieve in the next component. I'll go for spline keyway where I need to locate this. Now I can drag this component, I can drag this design library and I can locate here. Once you locate this, it will ask you a point where you need to locate this point. You can go and choose the origin from this solid, and now you can see it is located here. And if you need, you can change the dimensions if you want to override the dimensions. Like this 7 I need to change, or 75 I need to change, I can change it to 65. You can change this and click OK here. This is how we can create design library, and you can use multiple times in different parts as per your requirement. Keyways, spline keyways, and different type of company logos, you can save it as a sketch format and you can place wherever you require. That's all about creating design library in SolidWorks. Configuration in SolidWorks help you to create multiple variations of your part or assembly model within a single document. This will avoid the repetitive work involved in creating a part. All what you need to do is you can create two type of configurations. One is you can create configuration based on the dimension, and one you can create configuration based on suppressing the feature. Now let's see how we can create this configuration in SolidWorks. Let's see here how we can do this. This is a stand which is used for validation. Now I need this fillet to be unsuppressed. Okay, and this model should be one configuration, and the next model should not have fillet, and I need to validate this. So do I need to create one more copy of this part? Not required. What you need to do is go and select this fillet and suppress. Now go to this configuration and right click, go to add configuration and give a name as without fillet and select here OK. Now this is without fillet, and default, if you double click, this is default, and you go and unsuppress this fillet. So now once again you go back to configuration manager, without fillet, double click, you will have configuration without fillet and you will have configuration with fillet. This is how you can configure the whole model, and this is one type of doing configuration. And let's see how we can do configuration based on the dimension. Here this is a link clamp. I need to create multiple copies, that is I need to have different variants, the same link clamp but in different sizes. What you can do is go and do once again configurations not required. Select this part, which dimension you want to vary. Select the dimension and go and right click it, go for configure dimension, and here we enter here as distance and 300, and here once again 300 I want to make it. Let's select this, make it as 300 and click once again, enter here as distance as DISTAN, distance as 150, and this should be 150 and click OK. And now if you click OK, here you can see three type of clamp is created here using configuration. Now once you save this file and once you open this file in the assembly, you will have three type of configurations. So which file you need, you can do this by using configuration. And that's all about doing configuration in SolidWorks. That is, you are doing configuration based on the feature suppression and based on the dimension. And based on dimension, I'm showing you one sample example. Similarly, you can control the pitch of the helical curve, or you can derive the configuration for the entire assembly between the distance between the two components in an assembly. You can make a configuration. And that's all about doing configuration in SolidWorks. Design table. Previously, we had seen creating multiple variants of the part using configuration. But in configuration, you can do only for one single dimension, and also doing configuration with one single dimension and controlling the whole part will be tough. So now we are going to see creating the variants of parts and assemblies by defining the parameters in the Excel sheet which is embedded in the SolidWorks environment. For this, definitely XLS should be installed. That is, Microsoft Excel software has to be installed in your machine so that you can use this to create design table. And here you can see one such example is given in this image. Let's see how we can do this. I will go to the ratchet wheel, and this wheel has to be created. This should have different variants. Let's see how we can create using design table. Go to insert, design table, design table, but we don't have here. What I will do is I'll go and see first configuration. Once again, it is there. I will just create. I will right click and I will delete this created one so that we can create newly. I'll go and say insert, table, design table, and click auto create so that we can select dimensions given by the software automatically, and you need to select from here to here. Click OK. Now you can see the XLS sheet embedded with this SolidWorks. You extend this, and now you need to have one more size. What I will do here, I will make it as size 150. Now what I will do is I will go and say size, no, I will make it as number slot 8. Here I'll make it as same 120, and here 20, and here 30, and here 360, but here I'll make it as 8, and here once again 30, and here once again I need this should be 4, and axis of revolution 30, 360, and here the parameters are same 30, 20 and 120, and this slot number is 4. But at the end we left this. I will enter this 30 also and just select outside the space. Now you can see a message will be shown saying that 2 slots has been created. Click OK, and now you can go and see in this configuration manager slot 4 and slot 8. And this is how you can create design table in SolidWorks, and you can create multiple variants using Excel sheet so that the whole parameters will be edited as simple as possible using Excel sheet. Working with views. As of now, we had seen creating variants using design table and using configuration. Now we are going to control the whole part with one single dimension, and that part will be parametrically controlled by using one single dimension. Let's see how we can equate all the sizes with one single parameter. Let's go to the SolidWorks environment, and this is the connecting rod, which is a link component. Which is a link component. Let's see which dimension we are going to drive. I will use this 80 to drive the entire part. To drive this, we need to go to Tools, go to Equations. In the equations, if you select this part, and if you want to add equation for the hole diameter, this is my hole, and the hole diameter I need to add, so I will select the hole. This is 80. First we need to select this equation and select this equation. Now you can see 80 is the D3, but I don't require it for this one. I will delete this, and now here I don't require. We need to add for the other thing. What I will do is this radius, that is hole diameter, and here I need to say D3, that is this dimension, and click OK here. And once again I'll go and choose the fillet radius. Here this 48, and 48 has to be derived with respect to the same dimension, that is D3. At the rate of I'll make it as D3 with a symbol like this, D3 at the rate of sketch 2, and once again the symbol, and we need to enter multiplication factor and 0.6, enter. Now we had applied 2 equations for this component, one for the hole diameter and one for the fillet. Let's see how we can control this. And now we can watch here all the parameters are controlled using D3 at sketch 2. Let's give OK here, and now let's see how we can control this. I'll double click this, that is 80. I'll double click this 80, and I will say this 80 should be 20 mm, and give Control B. Now you can see it is updated, and now if you double click and if you see, you can see it is 120. Previously it was different, and here you can see 30. This is how you can create the part using equations. And now it is easy once again for us to create design table, because you don't want to select all the dimension. One single dimension you can select, and that will be added to the Excel sheet. And if you modify one single dimension, you can create number of variants using Excel sheet. That's all about creating configuration, design table, and equation. Next let us see the other utility tools available in SolidWorks. How we can measure the geometries. The normal distance between two selected points, the vertical distance, horizontal distance, diameter, and how I can measure all this in SolidWorks, because this is very important when you are creating a part model, since you need to evaluate the model so that you can use this component for the assembly. And let's go to the knuckle joint, knuckle part shown here. How we can evaluate means I need to calculate the distance between these two holes. Go to measure, select this edge and this edge, it will give you the information. Here once again I will select this edge and this edge. I'm sorry, I will go once again, say this should be having this edge and this edge. Now you can see the center distance and dx and dy distance. And also you can see a big list which will be showing the distance between circle centers, distance, everything. And apart from this, if you want to understand the diameter or you want to understand the normal angle between these two faces, let us take this face and this face. You can see the angle between these two faces. This is how you can use the measure tool. Apart from this, we have advantage like measuring center to center for a circular edge, and minimum distance, maximum distance, which is measuring distance between two tangential endpoints. And also you can highlight the dual dimensions. You want to show in the document properties, which is predefined the settings, or you want to over define it. Means you want to show the same measurement in inches, and you want to also show the same measurement both in inches and millimeter. You can control from here. So these are the advantages we have in SolidWorks when you are creating this model, so that you can avoid the confusion in measuring the geometries. And next, one more thing is we have that is MOS properties. Let's see how we can measure this MOS properties. Until now, let's see this measuring geometries, other advantages. Apart from this, you can also measure the distance between two vertex also. That's all about measuring geometries using SolidWorks.